Hi everyone, and welcome to the Python crash course for absolute beginners. This video is meant for those of you who are very new to programming in general and wanted to get started out by learning Python. In this video, I'm going to cover all the essential information about Python that you'll need to know to get started as a Python programmer. I've split this crash course into 8 sections, and in each section we cover 1 or 2 key topics that you'll need to know. I've uploaded each of these 8 sections as individual videos on this channel if you prefer to watch them separately. Otherwise, I've compiled them all here in this video as a supercut to have it all in one place. Timestamps for every different learning topic will be in the description. Without wasting any more time, let's get right into the video. Enjoy. Python is a pretty awesome language, and I strongly believe that it's the best option for people who are just getting into programming. Python is an all-purpose programming language, meaning you can program a huge variety of different things with it, and it's extremely versatile. It is much simpler than other popular languages, but can still do some extremely powerful things. Python emphasizes readability, meaning it reads a lot like English and can be learned very quickly. Although Python is all-purpose, it excels especially in the following industries: AI and machine learning, data science, application programming, and even web development. All of these fields are very high in demand at the time this video is being uploaded, making Python one of the most popular, if not the most popular, programming language in the world. So I'm going to teach you everything you need to know about Python step by step. By the end of this course, you'll have a strong understanding of the language and be able to begin your Python development journey. To start off, let's set up our environment. To write any sort of code, we'll need a code editor where we can type and run our code. For this course, we're going to be using Google Code Laboratory. Much like Google Docs or Google Slides, Google Collaboratory is an online, cloud-based tool, and this one in particular allows us to edit and run Python code extremely easily. So we don't have to worry about any sort of installation of the Python language or any other third-party tools. And setup will only take us about 30 seconds. So first, open up a new tab in whichever browser you're using. In this case, I'm using Google Chrome. And go to colab.research.google.com. And once you're there, you'll see a page that looks something like this. Now, if you're used to using other Google tools, you'll notice that this layout looks fairly familiar probably. So let's create a fresh file to start coding in. Go to the top left of the screen, click File, and click New Notebook. If you're not already signed into a Google account, it'll now prompt you to do so. Now that we've opened up a new file, you should see this page that looks something like this, which is just a blank notebook with the name untitled.ipynb. Now ipynb is just the file extension, so let's change untitled to say hello world, and then press enter. Now let me quickly explain how Google Colab works. Before that, let me just zoom in so it's a little bit easier for you guys to see. Okay, so in Google Colab, you have what are called code cells, which are these dark boxes that have a run button on the left-hand side of them. Now, if I click this one right now, this run button, it won't do anything, obviously, because we don't have any actual code in there. But when you do have code and you're ready to type, you type in these boxes. So, super simple, let's test it out. To display any sort of output in Python, we use what's called a print statement. So to do that, I'll show you. So we type print, then parentheses, and notice if you type parentheses, it'll automatically autofill both the opening and closing parentheses. And then you want to put quotation marks as well, and that'll do the same thing where it's going to autofill both the opening and closing quotations. And then within that, we're just going to type hello world. And then now we just press the run button, and voila, hello world is displayed. So let's say you want to print something else as well. So let's click after this closing parentheses here, press enter to start a new line, and let's write print hello YouTube. And now if we go over and press play, you'll see that both hello world and hello YouTube are displayed. Now if we want to make a new code block, go to the top of the screen here and you'll see this plus code button. So click it, and now you'll see this new code cell appeared here. Now let's write print testing. And if we go over and press this button, you'll see it just prints testing. Now notice that it doesn't print hello world and hello YouTube because this run button only executes what is inside of its particular block. So it's only going to print testing. So for this video, I really just wanted to show you how to get the environment set up and give you a very, very basic overview of the Python programming language. So I'm going to go ahead and end this video here so it don't go too long. In next video, we'll actually start to dig into some real programming concepts like variables. Take care. Hi everyone, and welcome back to the Python for Absolute Beginners series. In this video, we're going to cover a fundamental part of Python, variables. Variables, in my opinion, are probably the most fundamental aspect of Python and just programming in general. So what is a variable? A variable is basically an alias to some piece of data. They allow us to easily store and access data. If you're familiar with algebra, you know that you can have letters that equal numbers, like x equals 5 for instance, and we would call x a variable. In programming is super similar, so we can assign any letter like x or even a word like sandwich to some piece of data. What kind of data can we store in variables? Let's quickly go over that. So Python has quite a few different types of variables, but we're going to focus on 4 in particular that I believe are the most basic and essential variables to start off with, and we'll get into more later. We have numbers, which are just numeric values, strings, and booleans. We break numbers into 2 categories, ints and floats. So let's start with int. Int represents any whole number. Examples of an int would be 1, 5, or 12. Literally any whole number you could think of. This is arguably the most common variable you're going to see. Floats represent any number that have a decimal value. Examples of a float would be 5.7, 1.8, and 9.0. If there's a decimal value in the number at all, it's a float. Even if it ends in a 0.0 like 5.0 or 8.0, it is still a float because it contains a decimal. A string is any combination of letters. Examples of strings would be the letter A, a whole sentence like hello my name is Austin, or hello world, or even just random letter gibberish like this. In Python and in most other languages, we always surround strings with either double quotations or single quotations. That's why, if you remember in the last episode, when we type print, we use quotations to type hello world because hello world is a string. The last type of basic variable that's super common is called a boolean. And if you're new to programming, you've probably never heard this term before. A boolean literally just means true or false. Booleans are super simple, but yet they play a huge part of Python and computer science in general. We'll talk a little bit about them in today's episode, but we'll dive deeper into booleans in the next episode when we cover something called conditional statements. So now that you have a basic understanding of the main variable types, how do we actually use them? Let's jump over to Google Colab that we set up last episode, and you can either continue writing in the same notebook that we made last time or just create a brand new one. So to assign a variable to an int, we write this, x equals 5. Now it seems super simple, but let me quickly just break this down so we're on the same page here. X is the name of our variable, and you can name it literally whatever you want. There are some naming conventions you'll have to follow to prevent errors, but the name of the variable can be pretty much anything you want it to be. The 5 is what we want our variable to equal, and this is basically the data we're storing. And this is where we're going to fill in either an integer, float, string, boolean, or so forth. In this case, we're using a 5, which is obviously an int. And lastly, this equals sign is something called the assignment operator. And it basically lets the computer know that you're assigning a variable. Technically, it reads from right to left, saying 5 is being assigned to the variable x. In other words, x is now storing the value 5. I'm going to quickly write a comment off to the side here. And comments are basically lines of code that are used just for the user to kind of document what they're doing and just write personal notes to themselves, so the computer actually completely ignores them. And if you want to write comments in your code, just type this little hashtag or pound symbol. So I'm just going to write just what I said here. X is variable name. 5 is data we are storing. I want to make a quick note here that the order of assignment here absolutely matters. So x equals 5 is not the same thing as writing 5 equals x. The variable name that you're creating should always be on the left-hand side like this, and the data you're putting in it should always be on the right-hand side. So if I have 5 equals x and I try to run that, I'm actually going to get an error here, and this error says can't assign to literal because we're trying to assign a value to a variable, which doesn't make sense in this order. So long story short, just keep the variable name on the left-hand side and keep the data you're storing in it on the right-hand side. So if we just delete this and run it again, error's gone, no problem. So now let's try and print out our variable. And we're going to be using the print statement that we showed you in the last episode. So make a new line here. We're just going to type print parentheses and then put our variable name inside of those parentheses. And notice how this time we're not actually using any quotations around the variable like we did when we were typing hello world. And the reason for that is because quotation marks interpret very literally. So if I typed print quotations x and I press run, it's literally going to print the character x. But if I remove the quotations and I run just print parentheses x and run it, it's going to print out 5. Before we move on, I just want to make a super quick note here so we're on the same page. These lines are going to run in order. So this first line here, x equals 5, is going to run first, and then right after it's going to run print x. And this is how Python works in general, so you got to keep this in mind that these lines run always from top to bottom. Okay, so now let's move on to the other variable types. I mentioned earlier that another type of data is called floats, which are basically just decimal values. Assignment is going to look identical to what we just did, except for floats will obviously have a decimal value instead of a whole integer. So let's actually create a new code block here, and we're going to do just that. So let's make a new variable, y, and instead of setting it equal to an int, we're going to set it equal to a float. So let's say 6.3. And if we want to print this variable out, we're going to write the same print statement like we did up above. So we're going to write print, parentheses, and then inside of that, put whatever the name of your variable is. And if we run this, you'll see it'll print out 6.3. And I should really mention now that there's a really neat thing in Python where if you want to check what the type of your variable is, because maybe you're not sure, you just want to see what the output is, there's actually a really easy function for that. So if I do underneath this line, I write type y, and I run that, the output should say float because y is of type float because it is 6.3, which is a decimal value. So if I run this, yep, you'll see 6.3 and then float. And I'm going to go ahead and add that type up here just to this one so you can see that x should output int. So we do type x and the output should be int. Perfect. So that's definitely a useful tool if you want to debug or just have that in general so you can check a type, maybe if you're not sure what it is. All right, so let's go ahead and assign a string here. So I'm going to open up a new code chunk. I'm going to just click on this block and plus code at the top just so I can insert a new block below this one. And remember for strings, I said that we always use quotation marks when we're assigning a variable. So let's say we want to have a string called hello world. Let's do z equals quotation marks hello world. And if we do the same thing we've done for all the other variables, we go down, print z, we press run, hello world is displayed. And again, just like the other ones, if you want to check the type of the variable and see what type of variable it is, you can always just do type, parentheses, and then your variable name, and that'll say str, which is just short for string. So let's make another code block here, and we're going to cover booleans. So remember that I said that booleans are either true or false. And we have pretty much two ways of actually assigning booleans. The first way is to literally assign it to the value true or false, like this. So let's make a new variable, my variable equals, oops, spell that correctly, my variable equals true. Now we can do that, or if we want to have something that equals false, we can also do something like my other variable equals false. And just a quick note, remember I said that variable names can be pretty much anything, so I'm just kind of making these names up as I go. I was using single letters up here just to save some time, but variable names can be whatever we want. So this first way here definitely comes in handy, and this is one way you can assign booleans. But the other way is to use something called logic operators. And logic operators are basically something that will evaluate to either true or false. And we'll definitely get a lot more into these into the next episode, but for now, just imagine we have less than signs and greater than signs. If you think about it, any expression containing a greater than or less than sign is either going to evaluate to true or false. If I ask you, is 5 less than 10, you're either going to reply, yes it is, or no it isn't. Meaning that it's either going to evaluate to true or it's going to evaluate to false, right? So I can actually assign a boolean like this. I can say my variable equals 5 less than 10. 5 less than 10 is either going to be true or it's going to be false. In this case, 5 is less than 10, so 5 is true. So this is going to basically say the same thing as writing this. My variable equals true, because 5 less than 10 evaluates to true. If we wanted to do false, same deal. we would do my other variable equals 5 greater than 10. Now obviously 5 is not greater than 10, so this is going to evaluate to false, which is the equivalent of writing something like this. So in summary, booleans are always going to be true or false, whether you actually write them as literally true or false, or if you write them as an expression that is evaluated as either true or false. So if we make two more lines down here just to print out these variables, we'll do print my variable, go one line down, print my other variable. And like I said, this should evaluate to true, and this should evaluate to false. So the result should be print true and then print false. And if we run it, yep, you'll see true and then false. So now you may be wondering, is it possible to change and update variables? And yes, it absolutely is. So let me go ahead and delete these code chunks here. So if you want to delete code chunks, we'll just go to this trash can button, delete cell. We're going to delete this so we can free up some space here and go back up to the top. And we'll just make a brand new one up here. So it is possible to update and change variables. So let's say we have a variable x equals 8. And say for whatever reason we want to change it eventually to x equals 6. So we can just do x equals 6 right below it. Now let me print these out just so I can show you how this works. If I make a line under this one and I say print x, and I make a line under this one that says print x, what do you think the result is going to be? Now remember I said that these run in order. So first I'm assigning x to 8. And then I'm printing x, so it should print out 8. And then I assign x to 6 and then print x again, so x should print out 6. So the result we should see is 8 and then 6. And if we run it, boom, you'll see 8 and 6. One of the unique things about Python is that we can actually change the same variable to a different type. So instead of x equals 6, let's write x equals hello world and then print it out. And you'll see that we have 8 and then hello world. So this is kind of a unique thing in Python and it's perfectly acceptable, though I probably wouldn't recommend constantly switching around the type of a variable just because it doesn't usually make a lot of sense to do so. So let's delete this chunk here, and I'm going to write 3 new lines. Let's say we have x equals 10, we have x equals 20, and then x equals 30. And then let's say at the very end of this chunk, we want to print out x. So with this code here, what do you think the end result is going to be? Remember, I said that everything in Python runs in order from top to bottom. So if I have this print x down here at the bottom, it should be equal to 30, because x equals 30 is the most recent line of code and therefore is the most recent update for x. So if we run this, we should see 30. One of the really interesting things about variables is that you can actually assign a variable to another variable. So I'm going to go ahead and press the clear output button and then just delete this to free up some space for us. So let's say we have a new scenario. Let's say we have x equals 12. And we say, hey, we want to make a new variable y that also equals 12. Now we could just write y equals 12, obviously. But instead, x already equals 12, so we could write y equals x. And in this case, now y and x are both pointing to the value 12. Now note and remember that the order of this always matters. So the variable on the left-hand side is the new variable we're creating or updating. So saying y equals x makes sense, but writing x equals y would not make sense. So we're creating a new variable y, so we put that on the left-hand side, equals x is the value we want to store. So now if we go down, we print out x, and then we print out y. They should both be equal to 12. Next, let's go over some basic math operations that we can use in Python. Just like basic math, we have 4 main math operations in the Python language. There's actually also a 5th one that we'll talk about too, and I'll go over that a little bit later. So the basic operations are addition, subtraction, multiplication, and division, and hopefully those all sound pretty familiar to you. The 5th one is called modulus, and I'll go over that one last. So let's open up a new code chunk here. Let's open up a print statement. So let's say we just want to do some basic arithmetic, some basic math here. And we want to start with addition first. So addition, we're going to use with the plus symbol. Let's say we want to do 5 plus 5. We're going to print that out. The result is 10. Pretty self-explanatory. Let's say we want to have more than just two numbers. We can do 5 plus 5 plus 7 plus 9. Press play, we get 26. So Python computes this very quickly and it's very easy to do math. Let's say we want to do subtraction, right? We'll do 8 minus 5, run that, 3, awesome. So we know subtraction is pretty easy. We can also add more than two numbers if we want, like this. That outputs 1. Let's say we want to do some multiplication and division. So multiplication, we would use this asterisk symbol, which is on the 8 key on your keyboard, or some people just call it star. And this is how we do multiplication in Python. So let's say we want to do 4 times 4, run that, 16. Same thing as before, we can do more than two numbers, 4 times 4 times 4, we're going to get 64. Now, lastly, let's say we want to do some division. Division in Python uses the / operator. So let's say we want to do 10 divided by 2, we would do 10 / 2. We go run, and we get 5.0. The great thing about math in Python is that it's pretty easy and self-explanatory because we're using the exact same math operations that we learned as kids in school. The fifth operator is called modulus, and you probably haven't heard of this term before. And modulus is represented by the percentage symbol. So let me just write this off to the side. Modulus is percentage symbol. So let me quickly explain what modulus is. So modulus is very similar to division, except it gives you the remainder between two numbers. So if you recall when you first learned division, you probably learned about finding remainders. For example, if we wanted to write 10 divided by 4, and we output this, 10 divided by 4 doesn't divide evenly. As you can see, if we run it, the result is 2.5. But let's say we wanted to divide using only whole numbers. We could say that 10 divided by 4 is equal to 2 with a remainder of 2. What about 10 divided by 3? 10 divided by 3 doesn't divide evenly either. If we run it, we're going to get 3.33333 repeating forever, right? Or instead, if we're using only whole numbers, we could say 10 divided by 3 is equal to 3 with a remainder of 1. And the modulus operator just returns that last remainder number. So when I write 10 modulus 4, the remainder should be 2. So let's write 2 here. Boom. If I wanted to do 10 modulus 3, remember I said the remainder should be 1. So we should print out 1 here. And if, say, we're trying to do a modulus operation on numbers that actually divide evenly, like 10 modulus 2, obviously there's no remainder in there since they divide evenly, so the modulus result is 0. So the reason I actually wanted to go over arithmetic and basic operations in Python is because they come in handy when you're assigning or updating variables, and you can freely do operations between variables, as long as they're of the same type, relatively speaking. So let's say we have a new code chunk here. Let's say we have x equals 5. Now we want a new variable y that equals 5 times the amount of whatever x is. So we can make a new variable y that equals x times 5. And if we go and print both these out, we should get x is equal to 5 and then y is equal to 25. So let's run that, and you can see we get 5 and 25. And let's even say we want a new variable. Let's go ahead and delete these print lines here. Let's do a new variable z that is equal to x plus y. And then now we just want to print out z. We already know that x is 5, y is 25. So now we're doing z equals 5 plus 25. Printing that out, and we get 30. So I think now you should have a pretty solid grasp of variables in Python. We've covered what the different variable types are, like ints, floats, strings, and booleans. We also covered how to assign variables, how to print them, and how to do different operations between variables, including math operations. Before we close this video out, I want to quickly cover one more thing, and that's variable naming conventions. So let me go ahead and delete all of these blocks here. Let's go back up to the top, and we'll make a new one. I mentioned earlier that you can name a variable pretty much anything that you want, but there are a few rules that you need to follow. So a variable can only contain numbers, letters, or the underscore character. But the caveat is that they cannot start with a number, or else the computer gets confused and will throw an error. Another rule is that it cannot have any spaces in it. So let me just write out a couple of examples of variable names that work and are perfectly legal, and some that don't work and are illegal. So let's say we have legal variable names right here. Let's write out a few legal ones. And then let's write out a few illegal ones. All right, so as you can tell, all of these four here do abide by the rules. They only contain numbers, letters, or the underscore character. None of them start with a number, and none of them have any spaces in it. Now let's go through some of the problems with these variables down here and why they're illegal. This is illegal because it starts with a number, and we can't do that. This variable has a space in it, and then this variable has a hyphen. And the only special character that's allowed is an underscore. Hyphens are not allowed. So to sum it up, basically just don't start a variable with a number, don't have any spaces, and don't contain any special characters that aren't an underscore. And besides that, feel free to name variables whatever you want. Now, typically when naming variables that are multiple words long, we use something called camel case or snake case. These are both naming conventions that make variable names more readable. So camel case, let's write camel case here. Camel case is when we capitalize the first letter of each word except for the very first word. So an example of camel case would be my var, written like this. Let's say my variable name, like that. So we can see that we're capitalizing the first letter of each word except for the first one. And snake case, let's write snake case, is something similar, except instead of separating it by capitalization, we separate it by underscore. So the equivalent of these two in snake case would be my underscore var or my underscore variable underscore name. Now, I personally prefer camel case, and you'll probably see me using camel case throughout these tutorials, but it really just comes down to personal preference. So this video is getting to the point where it's fairly long now, but we've touched base with the fundamentals of variables in Python now. You should now know what variable types are, how we assign variables, how we name variables, and how we can do math operations between different variables. Now there is a disclaimer that this video is probably going to be the longest in the series, so if you're able to get through this video, congrats, the rest will be quite a bit shorter. In the next episode, we're going to cover something called conditional statements. So take care everyone, and I'll see you then. Hi everyone, and welcome back to the Python for Absolute Beginners series. In this episode, we're going to cover something called conditional statements. A conditional statement is something that essentially dictates the flow of code. We can use conditional statements by operators called logic operators. I briefly mentioned them in the last episode, but we're going to fully cover logic operators in this episode. So a logic operator is an operator that goes between two values to form an expression, and will cause this expression to evaluate as either true or false. In the last episode, I mentioned less than and greater than signs, and those are both logic operators. We've got 4 more to cover today, but they're all pretty self-explanatory. The first one is the equals condition. This one is exactly as it sounds, and it checks if two values are equal to one another, and you write it by writing double equal signs. It will always be double equal signs, and this is super important because this is a very different operator from the assignment operator that we covered last episode, which is just one equal sign. This expression will evaluate to true if two values are equal to each other. One example where this is true would be 10 equals 10. One example where this is false would be 7 equals 9, which is pretty self-explanatory. The next operator is the not equal condition, and this operator is the exact opposite of the equals condition, and it checks if two values are not equal to each other. So we write it by writing an exclamation point followed by an equal sign. This expression will evaluate to true if two values are not equal to each other. One example where this is true would be 8 not equal to 10. One example where this is false would be 10 not equal to 10, so also pretty self-explanatory. The next operator is the greater than sign, which we showed last episode. This operator checks if the first number is greater than the second number. If the first number is greater than the second number, this expression will evaluate to true. One example where this is true would be 5 greater than 3. One example where this is false would be 3 greater than 5. And the next operator is greater than or equal to. This is almost identical to the above condition, except it also checks whether or not the values might be equal. If the first number is greater than the second number, or the two numbers are equal, this expression will evaluate to true. We have the same examples for this one as the above one, but just keep in mind that the values could be equal and make it true. The next operator is less than, which you also saw in the last episode. This operator checks if the first number is less than the second number. If the first number is less than the second number, this expression will evaluate to true. One example where this is true would be 3 less than 5. One example where this could be false would be 5 less than 3. And the very last operator is less than or equal to. This operator again is very similar to less than, except it also checks if the values are equal. If the first number is less than the second number, or if the two values are equal, this expression will evaluate to true. Again, we'll use the same example for this one as the above one, but keep in mind that the values could also be equal and still be true. So now that you understand what the 6 logic operators are, let's go over how to actually use them. These operators become useful when you want to write statements called conditional statements that can control the logic flow of our code. So with conditional statements, we have 3 keywords that we're going to want to know, and I'll just comment these here. So we have if, we have elif, which just stands for else if, and then we also have else. And with these keywords, we use logic operators. So let's say we have a scenario. Let's say I want to run a block of code, but I only want to run it if 5 is less than 10. So let's check that. So let's space down 2 lines, and let's write if parentheses 5 less than 10. Now after the closing parentheses, type a colon, and then press enter. And then from here, we're going to type print 5 is certainly less than 10. Now let me explain what's going on here. So this if right here signifies a conditional statement, and it's going to check if whatever is inside of the parentheses is true. If what's inside is true, then we will run whatever code is indented underneath the if statement. A colon after the conditional statement lets the computer know that the very next line is going to be indented, and this is how Python organizes its code. If you forget a colon, or if you forget to indent, the computer is going to throw an error. In most Python editing environments like Google Colab, once you type a colon, the next line should automatically indent for you. But if it doesn't, just use the tab key to indent yourself. Now let's run this code to see what actually happens. So if we run it, and we'll give it just a second, you'll see that it prints out 5 is certainly less than 10. So we wrote that if 5 is less than 10, then we're going to print out this statement. And 5 is certainly less than 10, so this evaluates as true, so this piece of code is ran. And we can actually put as many lines under an if statement or any conditional statement as we want. So say I wanted to print more things under here, like print blah blah blah, and then I'll print something else. I'll just say print still inside if statement. And then I run it again, it's going to run all these, because as long as these are indented underneath the conditional statement, it's going to tell the computer that we're still inside the if statement. But when we want to get out of the if statement, we're going to unindent. So let's unindent here, and let's just print now we are outside of the if block. And if you'll run it, you'll see all 4 of these will print, but just know that this 4th one here prints outside of the if statement and not inside of it. So let's test something then. If we change this if statement to say if 5 is greater than 10, then this block of code with this if statement isn't going to run at all. And why? Because the expression inside of our conditional statement, this 5 greater than 10, is not true. And a conditional statement is only going to run if this piece of code right here is true. So if we run it, you'll see that it's only going to print now we are outside of the if block, because basically what happens is we hit this line, we say, hey, is 5 greater than 10? No, so we skip all this code because it's inside the if statement, and we instead just go to this line of code. Instead of just using two random numbers like 5 and 10, let's use what we learned last episode to implement some variables. So let's make two new variables up here. Let's make x equals 5, and then we'll make y equals 8. So let's go back into this if here, and then replace the condition with x less than y. And we're going to go ahead and delete this code here. And we're just going to print out x is certainly less than y. So what do you think is going to happen here? So we have x equals 5 and y equals 8, which means that x should be less than y, so this line of code should run. And if we run it, we'll see that it does in fact run. Where if statements become powerful is when you combine them with elif and else statements. Elif just stands for else if, and it basically means if the first condition isn't met, let's check this other condition instead. So below our current if statement, let's make a new line and unindent to let the computer know that we're outside of this block. And let's write elif parentheses x greater than y. And we'll type a colon and then press enter. And then we're going to write a print statement that says it appears x is greater than y. Now, if this first statement isn't run, this elif statement will say, hey, let's try this condition instead. So in our case, we're first checking if x is less than y. If it is, we'll enter this block of code. If it isn't, we're going to keep moving and check this elif statement, and if this is true, then we'll enter this block of code. So let's change our variables around here so that we trigger the second elif block. So let's say x equals 10 and y equals 6. And now, if we press run, you'll see it prints out it appears x is greater than y. You can actually have as many elif blocks as you want, so let's change the conditions of our variables. Let's just look at the x variable. So in our first statement, let's change x less than y to say x equals 7. In our elif statement, let's change this just to say x equals 9. And we're just going to change the text here. For the if statement, we're going to say now inside if statement. And then for the elif, we're going to say now inside first elif statement. And then we can make another elif block. So let's make two more actually. So I'm going to copy this and just paste it. So now we've got a couple of elif blocks, and let's change the conditions of these. So let's change, let's say this one to x equals 5. And then finally, we want this elif block to trigger. So we're going to set this to x equals 10, because we know we set x equal to 10 up here. So we'll say this is the second elif block, and this is the third elif block. So what's going to happen here is if we run it, it'll say now inside third elif statement, because what we're doing is we're going to the first if statement. We're saying is x equal to 7? No, it's not. So go to the next elif. Is x equal to 9? No. So we skip that. Is x equal to 5? No. So we skip that again. And then we say is x equal to 10? And actually, yes, it is equal to 10. So we're going to enter this block of code and then print out now inside third elif statement. The last conditional statement word we need to know is else. So else basically runs if everything else has not been met. So it's basically like a default. It says, hey, all the conditional statements that came before me have failed to execute, so let's run whatever is in my code chunk. An else statement has to come after an if or an elif, as it wouldn't really make sense to have an else statement just sitting by itself. And unlike elif, there can only ever be one else statement in a continuous series of conditional statements. So in the example that we have currently, let's add an else statement at the very bottom. Let's say else, and then we're going to print the value of x could not be found. And notice that the else doesn't take in any parentheses or parameters here like the other ones, because it's a default, so it's just going to trigger if nothing else does. So we don't need anything like this inside the else statement. So let's change the conditions here so that we actually do enter the else statement. So instead of having this elif statement say x equals 10, let's say x equals 12. So now we're going to go through all of our conditions. We're going to say, is x equal to 7? Nope. Is it equal to 9? No. Is it equal to 5? No. Is it equal to 12? No. And because nothing else has been triggered, now we're going to enter this else statement. So if we run this, it's going to print the value of x could not be found. The most common combinations of conditionals, at least in my experience, are either just one if statement by itself, one if statement followed by an else statement, or one if statement, one elif statement, and one else statement. Although sometimes you may need to use multiple elif statements. One of the really cool things you can do with conditional statements in Python is having multiple logic operators. So in all of our examples here, every conditional statement has only one expression inside the parentheses. Let's say, however, we want one of our blocks to check for multiple conditions. Let's say in our first if statement, we want to see if x is equal to 5 or if x is greater than 7. And we can actually do just that by writing the or keyword. So like this, let's say x equals 5 or x greater than 7. And the OR keyword makes it so that if either of the expressions are true, the conditional will run. So in this case, x is not equal to 5, but it is greater than 7, so we're going to run this conditional block, and it's going to print now inside if statement. And we also have the AND keyword. The AND keyword makes it so that both of the conditions have to be true. So if we do x equals 5 and x is greater than 7, this is not going to run, because even though x is greater than 7, it is not equal to 5, so the AND operator does not let this code run. So if we run this, we'll see that it again defaults to the else block. So let's do a little bit more practice. I want to set up a little testing program here that allows you to easily test how these conditional statements work. So I'm going to delete everything. I'm going to delete all this. I'm going to clear out the output. I'm just going to make sure we have a fresh notebook here to work with. And I'm going to make a new variable called, let's just say, user number. And I'm going to assign it to input, parentheses, quotations, enter your number here. Now, input is a built-in function in Python that basically captures input from the user. And whatever is inside of the parentheses, in our case, enter your number here, is displayed to the user when the user is prompted for the input. So once the user types in their number and presses enter, we capture that input, and in our case, I want to assign that input to a variable I just made up called user number. So I'll show you how this works. And actually, let's make another statement here where we're going to print out whatever the user entered. So if I press run, there's going to be a little text box that shows up here. So it says enter your number here. And let's say I want to say 59. And then I press enter. It's going to capture that and store that value inside user number, and then it's just going to print that out. So this is where our conditional statements are going to come in. So let's say we have a conditional that checks what the letter grade of our user score is. So let's write a conditional flow that prints out a certain line of text depending on what the user enters. So we're going to assume a grading scale that 90 to 100 is an A, 80 to 89 is a B, 70 to 79 is a C, 60 to 69 is a D, and anything below 60 is an F. So let's write this below and just follow along with my code here. So I'm going to make 2 lines under here. I'm just going to say if user number greater than equal to 90 and user number less than equal to 100. And if this is true, I'm just going to print out you have scored an A. And what this is saying is if whatever number the user inputs is greater than or equal to 90 and it's less than or equal to 100, meaning it's in the range 90 to 100, then we're going to print out that they have scored an A. And let's make some other statements to check for the other letter variables. So let's make elif user number greater than or equal to 80 and user number less than or equal to 89. And then we're just going to print you have scored a B. And then I'm just going to copy and paste some of these down to make it a little easier. Make sure this is unindented. We're going to print these. And then we should have 5-letter grades because we have A, B, C, D, and F. So we'll have this one say between 70 and 79. And then this one is 60 and 69. And then this one for F should say if it's greater than or equal to 0 and less than or equal to 59. And then, oh, there's a little typo here. Let me change these. So they're lowercase. And then we'll change the text within each of these. So we have this block here should represent scoring an A. This is getting a B. This is getting a C. So let's change this to C. We'll change this little face here. And then we have another elif statement for D. So let's say you have scored a D. And then we'll say you have scored an F. So the conditions we've written in here should check all the numbers from 0 to 100. But what if the user enters something that isn't between 0 and 100 or is in some like invalid value? So let's write an if or an else statement, sorry, at the bottom here. That's a default. That's going to say you entered an invalid number. And basically what this is going to do is in each of these, we're going to say, okay, is it between 90 and 100? That's an A. 80, 89, B. 70, 79, C. 60, 69, D. And then between 0 and 59 is an F. And then if for some reason the number wasn't caught in any of these, we're just going to say that, hey, the user entered an invalid value. Okay, so I want to go ahead and run a couple of tests here. So let's go ahead and run this. And it'll prompt us to enter a number. Let's say we want to have somebody score a D. So let's put in 64 and we're going to press enter. Oop, it looks like we got an error here. Oh, okay, I see what happens. So this, I guess this input statement here, when it captures the user input, it's actually storing my input as a string and not an integer. So to get around that, we can actually wrap this in the int little function here. That basically will just convert what our input is to an integer. So let's try running it now. It should fix that. Let's do 64 again. And yep, it'll say you have scored a D. And then let's just run a couple of tests here. Let's say, hey, somebody scored an 87. What should that be? That should be a B, right? So we say 87, press enter, you have scored a B. Let's check for an A. Let's say they scored 98. You have scored an A. Let's check the bounds here. So let's check 100 and 0. So 100 should be an A, right? Yep, so you've scored an A. Let's check if they scored 0. 0 should be an F. Yep, you have scored an F. And then we also want to check our else statement. So let's say the user enters 16,547. Now that's not a valid grade, obviously. So what's going to happen is it should trigger this else statement because it's not within any of these ranges here. So we do that and it says you have entered an invalid number. Let's try another invalid number. Let's say 135 and I'll run that invalid number. And then you can just keep testing this as much as you want. So if you want on your own time, you can make a copy of this code here. If you want to just mess around with these conditional statements, it can kind of give you a good idea of how these statements actually execute. But one more time, we'll just say we want to get a C. Enter your number here. Let's enter 76. Press enter. You have scored a C. Okay, so by this point, you should have a reasonably strong understanding of conditional statements in Python. In this video, we learned what logic operators are, what if, elif, and else statements are, and how we can use these all to control the flow of code in our program. I'm going to link a couple of resources in the description below if you're still struggling to understand the concepts behind this video. Next video we'll go over data variable types that can hold multiple pieces of data instead of just one like the types we've learned so far. Take care everyone, and I'll see you for the next video. Hi everyone, and welcome back to the Python for Absolute Beginners series. In this episode we're going to cover data types that can store collections of data. So in episode 2, we went over variables that store just one value. Whether it was a string, int, boolean, or whatever else, our variable only ever stored one value. There are many times in coding, however, that we find the need to have variables that store more than one value. For instance, what if you wanted a variable that could hold all of your friends' names in it? We'll need a variable that can store multiple values for that, and that's where we're going with today's episode. We have 4 types of data in Python that can store multiple values in it, and I'm going to go over each one. They all share similarities to some degree. The first one we have, and probably the most commonly used, is a list. A list can have duplicate values, it is ordered, and it is changeable. Changeable just means that we'll be able to update the values in the list whenever we want, and ordered means that the items have a defined order that will not change. A list would look something like this. We always denote a list by using the square brackets, and we separate list items by commas. In our example, we're storing 3 strings that each represent one fruit. Oranges are in the first spot, grapes in the second spot, and apples are in the third spot. We can add as many other things as we want to the list, but oranges will always be first, grapes will always be second, and apples will always be third. Unless of course we delete these values from the list or something. Another example of a list storing ints would look something like this. An extremely important aspect of lists is what's called indexing. Indexing means the ordering of the values. We say that the first element of every list starts at index 0. The next value is at index 1, the next is at index 2, and so forth. So in this case of a list that has oranges, grapes, and apples, we would say oranges are at index 0, grapes are at index 1, and apples are at index 2. This index number is super important because this is how we're going to be accessing and modifying data in our list. Next we have a tuple, and a tuple is almost identical to a list except there is one main difference. Values in a tuple cannot be changed. This means that we can't add, delete, or modify any values inside of a tuple. Aside from that, it operates very similarly to a list. We write it almost the exact same too, except instead of using square brackets, we just use parentheses or round brackets. So we would write a tuple like this. The same rules also apply as a list. We separate items by commas, and the items will be in the same order every single time. If we wanted a tuple of ints, we could have, for instance, 5, 3, 8, and 7 in a tuple. Just know that once we create these tuples, their values cannot be changed or modified in any way. Tuples have the same indexing as lists. The first value is at index 0, the next value is at index 1, and so forth. The next one we have is a set. Sets also share some similarities with lists and tuples, but are a bit different. Sets, unlike lists and tuples, are not ordered, meaning if I have a set that contains 3 items, those items are not always going to be in that same order. Another key thing about sets is that they are partially changeable. Existing values in a set cannot be modified, however, you can freely add and remove items from a set as you please. We write a set similarly to how we write lists and tuples, except we use squiggly brackets for sets. So just remember, a list is square brackets, tuples is parentheses, and set is squiggly brackets. Another important thing about sets is that duplicates are not allowed, meaning we can't have the same value twice. Let's take an example of a set that looks like this. Right now we see it in the order of 10, 20, 30, and 40. But because a set is unordered, it could be 20, 30, 10, 40, for example. Sets always print out in a random order. Imagine that lists and tuples, which are very similar structures, are like people in a single file line. Everyone is in a particular spot and that order will never change. Sets, however, are like a room full of people that are constantly moving around. There's no order, so anyone could be anywhere in the room at any given time. In terms of how these data types relate to each other, lists and tuples are like fraternal twins, and sets are like that third sibling that don't quite fit in with the other two. If we have 2 fraternal twins and 1 misfit sibling, this last data type is like the distant cousin. Dictionaries are the 4th type, and they're very different from the other 3, yet also the most unique. Dictionaries, rather than just storing data on their own, use what are called key-value pairs. A dictionary would look something like this. Notice that we use squiggly brackets for dictionaries, just like we do for sets. One key-value pair from this dictionary would be brand Chevrolet, displayed like this. Brand is the key, and Chevrolet is the value. We always denote a key-value pair by writing whatever a key is, then a colon, then whatever the value is. A key is basically telling us what kind of value it is storing. If we have a key named brand, and we're specifically talking about cars, you can probably assume the value associated with it is going to be some sort of car brand. Similarly, if we have a key-value pair where the key is name, we know the value associated with it is going to be someone's name. A key has to be a string, but a value can be of any type. Notice in the above example that all of the keys are surrounded by quotes because they are strings. Some of the values, like Chevrolet and Malibu, are surrounded in quotes because they're strings, but for instance, we can have an int like 2008 as a value too, so we're not limited to just strings in the value fields. We separate key-value pairs by commas, just like we would separate list items by commas. Dictionaries are ordered, just like lists and tuples, meaning key-value pairs will always appear in the same order. Dictionaries, also like lists, can easily be changed and modified as we please. Dictionaries do not allow duplicates. You can almost think of dictionaries like tables, like this. Dictionaries are used pretty often, and they're very useful in a lot of different scenarios. So now that we've gone over the 4 collection data types, I want to show this graphic here, just so you can visualize the similarities and differences between all these different collection types. Lists are ordered, changeable, allow duplicates, and we write them by using square brackets. Tuples are ordered, unchangeable, allow duplicates, and you write them by using parentheses or round brackets. Remember, lists and tuples are almost identical except for the fact that tuples cannot be modified at all. Sets are unordered, partially changeable, don't allow duplicates, and we write them by using squiggly brackets. Dictionaries are ordered, changeable, do not allow duplicates, and just like sets, we write them by using squiggly brackets. The way we differentiate dictionaries from sets is that dictionaries use key value pairs and sets do not. So we've talked about what each data type is, so now let's actually code them. Let's go in order of how I presented them, so let's start with lists and tuples. Because lists and tuples are almost identical, I'm just going to cover both of them at the same time. So let's make a new variable, let's call it myvar, and let's make it equal to a list. So I'll make it equal to 1, 3, 5, 7, and 9. And notice how for a list we use square brackets and we separate each entry by a comma. Now because lists and tuples are ordered, we say every number has a certain index, which basically means the position that it is in. Every list and tuple starts with index 0 and just goes up from there. So in our case, at index 0 we have 1, at index 1 we have 3, at index 2 we have 5, at index 3 we have 7, and at index 4 we have 9. This index number is how we access data. So let's say we want to grab 5 from this list. What index is 5 in? Well, we have 0, 1, 2, so we know that 5 is in index 2. So if we want to access that, we write something like this. So square brackets are always going to be what we use to access list and tuple values. And inside of those square brackets, we always put an index number. So this statement is basically saying, hey, let's look at myvar, which is a list, and then let's look at whatever is in index 2. And let's actually wrap this in a print statement here so you can see. And if I run it, index 2 should output 5. Yep, so if we run it, you'll see we get 5. So what if I want to grab a different number? Let's say I want to print out this 3. So what index is 3 in? Well, 3 is in index 0 and 1. So we know 3 is in the first index. So let's, instead of printing myvar index 2, let's print myvar index 1, and it should output 3. So note that in this list, we only have indexes 0, 1, 2, 3, and 4. So if I try to access index 5, I'm actually going to get an error because it doesn't exist. So if I try and do this, index 5, this error is going to say list index out of range. And that literally means I'm trying to access part of a list that doesn't actually exist. So if I just want to print the entire list out, say, let's clear this output here. If I want to print the entire list out, I would just remove this square bracket here. And just like any other variable, I would just type print and then the variable name, run it, and you see it prints out the entire list. Let's say I want to change a value in this list. Let's say I want to change this 3 to a 6. To do that, we'll need to know the index that it's at. Well, we already said we know that 3 is at index 1. So let's write it like this. I'll make a space here. So if we want to modify a value, we'll use the same square brackets I already showed you. So we write myvar at index 1 equals 6. Now this statement is basically saying store the value 6 at the first index of myvar. So now if we run this, which is going to print out the entire list, you'll see we now have 1, 6, 5, 7, and 9. Let's say I want to change this 7 to a 15. So we'll do myvar. We know that 7 is at index 3, so we'll do myvar at index 3 equals 15. And now if we print it out again, you'll see that 7 has now been replaced by 15. What if we wanted to add and remove values from a list completely? To add values, we use the .append method. So let's say we want to add 17 to the end of our list. So let me make a space here. And to do that, we're going to write the name of our list, .append, and then put parentheses. And then whatever value you want to add to the list, you put inside the parentheses here. So we're going to add 17. And now, if we run all this code, which is going to change this 3 to a 6, it's going to change the 7 to a 15, and then it's going to add a 17 at the very end. So if we print it out, you can see it did just that. What if we instead want to add a new item to somewhere else in the list that isn't at the very end? For that, we can use the insert method. So the insert method has two values that you need to put inside of it. The first one is the index you want to insert at, and the second one is the value that you actually want to insert. So let's say I wanted to insert the integer 3 at index 2. I'll make another space here, and I would just write myvar dot insert. And then like I said, the first value should be the index we want to access. So we said we want to go to index 2, and then we want to insert the value 3. So now if we print this out, you'll see that at index 2, it just added a 3 and it pushed everything else over. What if we want to remove a value from a list? It's super similar to append, except instead of writing append, we write pop. So let's say we actually don't want this 17 at the end of our list anymore. So let's write myvar.pop. So after all these statements, I'm gonna make more space, scroll down a little bit so you guys can see a little better. We write myvar.pop, and then make sure to add parentheses. If you write it like this and don't put any number inside of these parentheses, it'll automatically remove the very last item on the list. So if we run this statement, you'll see, bam, the 17 is now gone. So we can actually specify a specific index with pop if we don't want to remove only the last item. So let's say we want to remove this 6. Well, we know this 6 is at index 1 because we have 0 and then 1. So let's say we just pop whatever's at index 1, and now we print it, and the 6 is gone. We've covered a ton of information about list in the last couple of minutes. So let me summarize everything so you can get a more clear and concise picture. So I'm going to go ahead and delete all of this here. I'm going to make some comments here. So to make a list, we write whatever we want our list name to be. Let's say my list. We write equals, then do square brackets, and can insert whatever we want inside of here, separated by commas. The index of a list represents the position. The first item of the list is always at index 0, and we just go up from there. So we have index 0, index 1, index 2, and index 3. To access a list item, write the name of the list variable, in this case, my list, then square brackets, and then whatever index you want to access. So if we want to access 5, this is at index 1, so we write it something like this. To update a list item, write the name of the variable, so we'll write my list, then square brackets of whatever index you want to use, so we'll say 2, and then set it equal to whatever value you want to update it with. So let's say 10. So in this case, index 2 represents 7, so we're replacing 7 with 10. To add an item to a list, we would just write the name of our list, dot append, and then add whatever value you want to add inside the parentheses. So let's say we want to add 3. Next, to add an item to a list at a specific index, we use the insert method. So we would write my list dot insert parentheses, and then the first value is the index we want to insert at, and the second value is the value that we actually want to insert. So let's say at index 1, we want to insert the value 40. To remove an item from end of the list, we would use the dot pop method. So in this case, we would write my list dot pop, and that will remove the last element of the list. To remove an item from anywhere in the list, so to remove an item from anywhere in list, we would use the dot pop operator, except we would put whatever index we were to remove at. So let's say we want to remove the value at index 2, we would write mylist.pop, and in parentheses, we'd put 2. I know so far this is a ton of information all at once, so feel free to come back to this video whenever you need to use it as a reference. I'll also drop a few links in the description that basically have all this information that I just mentioned. We're going to be using lists all the time, so there's a good chance you'll see lists being used in the coming videos as well. Tuples are going to be pretty much the exact same as lists, except you don't have access to these append, insert, and pop methods. You also can't update any tuple values, and that's because we mentioned earlier that tuples are unchangeable. The only difference in how you make them is using parentheses instead of square brackets. Let's make a tuple now so I can show you what I mean. So let's go ahead and add another code block underneath this one. And let's write a new tuple. Let's say my tuple, let me scroll down here. My tuple equals parentheses, yes, comma, no, comma, maybe. Oops. So I can still print out and access tuple values just as I can with lists like this. If I write print, and then we do the tuple name. So we do my tuple at index, let's say index 1. And if I print it out, it should print out no, because no is at index 1. But if I try and update it in any way, so let's say we try and update this. Let's say we do my tuple at index 1 equals LOL. And I try and run it, I'm actually going to get an error here. It'll say tuple object does not support item assignment because you literally cannot assign anything in a tuple. So if I try and use another function like append, let's say we use append, which obviously we can use with list. Let's say for a tuple I try and do dot append, let's just add haha on the end. Try and run that. I'm also going to get an error saying there is no attribute append because it basically doesn't recognize this method at all because we can't add or remove anything from a tuple. So tuple values can never be changed or modified in any way. So hopefully now you should have a pretty strong understanding of how lists and tuples work. So now I'm actually going to delete this code chunk here, and I'm going to make a new one, scroll down to it, and now I want to cover set. We said that you initialize sets by using squiggly brackets, so let's make a new set containing some strings of fruits. So we'll make a new variable, mySet, and set it equal to just some fruits here. Say bananas, we'll say grapes, and then we'll say apples, and then let's say oranges. And if you remember, one of the main rules of sets is that they are unordered. So if I actually take my set and I print out the whole thing, you'll see that it's not necessarily going to print in the same order that I initialize it in. So you see when I print it, it goes apples, oranges, bananas, grapes, which is a completely random order. And if I run it over and over again, it's going to print in the same order each time in this case, but just know that this ordering is kind of happening behind the scenes, in that like with lists and tuples, if we were to print it out, it would print exactly in order, but because it's a set and it's not ordered, this is going to be just kind of randomized almost. Because of this unordered aspect, we actually can't use square brackets to access individual values in a set. Another thing to note about sets is that they are partially changeable. When I say partially changeable, I mean that you can add and remove values from a set, but you can't update existing values. So for instance, I can add cherries or blueberries and whatnot to the set. So if I wanted to, I could also remove these values from the set once I felt like it. But I couldn't change one fruit, say from oranges to pineapple, because sets don't allow you to update or modify existing values. To add values in a set, we use the .add method. So if we wanted to add, let's just say a number, 25 to this set, we would write something like this. We would write mySet.add, and then inside parentheses, we would print 25. And if we run this, which will print out the entire set, you'll see it'll now have 25 in it, although again, the order is randomized, but we still added 25. If we want to remove an item from a set, we use the .remove method. You can actually use .pop to remove set items, just like we could with lists, but because the set is unordered, it's going to remove a random element, which usually isn't what we want. So to remove something, we would write .remove, like this. So let's say we decided we actually don't want this 25 anymore, so we'd write mySet.remove, and then inside of the parentheses, we would put 25. And if we run this now and print out the entire set, you'll see that 25 is now gone. Because you can't access any individual set elements by themselves, the only way to access them is by iterating through the entire set or iterating through every single item. So we can iterate through all items of a list and tuple as well. That's a whole other topic though that we'll cover in the very next video. So just like we did with lists, let me summarize sets for you. So I'll make some space down here, clear this output, scroll down. So to make a set, we would use whatever we want our variable name to be. So in our case, we'll say like mySet equals squiggly brackets, and then we can insert whatever we want here. Let's say 17, 25, and remember, set items are not indexed, so we can't access individual elements at all. So the only operations you need to know for now are add and remove. So to add to a set, we would just use the .add method. So let's say in my set, we want to add the value 32. So we do mySet.add parentheses, inside those parentheses, let's put 32. To remove an item, we use the .remove method. So let's say to remove item from set. And if you wanted to remove, let's say this 38, we would just write mySet.remove 38. Like I mentioned, we could also use the .pop method with nothing inside the parentheses, but that's going to remove a random item, so that's probably not the best option. All right, and finally, last but not least, I'm going to open up a new code block here so we can cover the last data collection type, which is dictionaries. So dictionaries are super unique and have quite a few different applications in programming. I mentioned earlier that dictionaries use key value pairs. So let's make a new dictionary so I can show you how they work. So let's just name it my dictionary equals squiggly brackets, and then just follow along here. So I'm writing a key that is name, then a colon, and then inside the name, I'll just put Austin, and then the next key value pair you want, let's just say email, and then I'll just make up some email here. Let's just say austin@gmail.com, and then separate another comma for our last key value pair. Let's say we want phone, so I'll do that, then a colon, and then I'll just write some made up phone number like that. So this dictionary has 3 key value pairs. The first one is this, name, with a key of name and a value of Austin. The next one is this, with a key of email and a value of this made up email address. And the last one is this, with a key of phone and a made up phone number. So same as the other collection sets, we can also print out the entire dictionary if we want to. So let's do a print statement, and let's do my dictionary. Let's run it, and you'll see it prints out the entire dictionary. To access items in a dictionary, we can use square brackets, sort of similar to how we access list and tuple items. Except dictionaries aren't indexed, so instead of putting the index number inside the square brackets, we put whatever the key of whatever value we care about. So let's just say I want to grab this email right here. So to do that, I would write my dictionary, square brackets, and then write email. So what this is saying is, let's look at the my dictionary, actual dictionary, and then let's grab whatever value has the key of email. So if I wrap this here in a print statement, you'll see that it should output this made up email address here. And yep, it does print it out right here. Let's say I want to grab Austin from this dictionary. So to grab Austin, I would just put in name right here. And we print that out, and you'll see it'll say Austin. Keys always have to be strings, so you're always going to have quotations inside of the square brackets here. So to change items in a dictionary, we use this exact same syntax. So let's say I want to change this name to, instead of Austin, let's just say Jackson. So let me make some space here, and I would write my dictionary name, and then let's just change it to Jackson. And then if we print it out here, you'll see when it prints the name, it prints out Jackson because we updated it on this line. The super cool thing about dictionaries is that this is actually how we add elements too. So if I wanted to add a key value pair to my dictionary, I would simply put a key inside the square brackets that doesn't already exist. So let's add something. Let's just say my dictionary, let's add a new key called birth month, and let's set it equal to October. And I'm actually going to delete this line here just so we can output the entire dictionary. And if we run this, you'll see that as a scroll bar here, but it added a new key value pair at the very end of it with just birth month and October. To remove an item from a dictionary, we would just use the .pop method. And inside the parentheses, we'll just put the key of the key value pair that we want to delete. So let's say I no longer want to have this entire email field here. So let's make some space. I would write my dictionary .pop, and then inside of the parentheses, I would just put email. And now if we print out the entire dictionary, you'll see that the email field is now removed. Let's say I also wanted to get rid of the birth month field. I would just do the exact same thing. So let's do my dictionary.pop, and then we'll pop off birth month. And now if we print it out, you'll see birth month is gone too, and now we just have name and phone left. Dictionaries have tons of use cases in Python, so I'd strongly recommend getting familiar with them. So since we went over these couple of things, let's quickly summarize dictionaries. So I'll make some space down here, and let's write to create a dictionary. We would just write our variable name. In this case, we'll just do my dictionary, equals sign, squiggly brackets, and then insert as many key value pairs as we want. So let's just make one that says name, colon, let's just say George, and then use a comma to separate different key value pairs. And then we'll say email, and then we'll just do LOL. So to type a key value pair, we write a key that will always be a string, so it's surrounded by quotations, and then colon, and then whatever we want our value to be. And then we separate different key value pairs by a comma. So next, to access items, so to access dictionary items, let me actually just clear this output here, we would use square brackets like this. So let's say we want to access this value George from this dictionary. We would write my dictionary, square brackets, and then the key of whatever is associated with that value. So we write name. To update items in a dictionary, we use the exact same syntax, except we can assign it a new value. So to update dictionary items, let's say we want to update the name that we just accessed. We would say my dictionary name. Let's just change it to insert name here. And that's how we update a value in a dictionary. To add items to a dictionary, go ahead and scroll down here. We just use the square brackets again, except we make sure that whatever we're putting inside the brackets is something that doesn't already exist. So let's just say we want to add a new field that says birthday, and then we'll just add in a month, let's say October. To remove items from a dictionary, so to remove items from dictionary, we use the .pop method and insert the key of whatever key value pair we want to remove. So let's say we want to remove the email field from this dictionary. We would write my dictionary .pop parentheses, and then we would type in email. So in this video, we covered the 4 data types that can store collections of data. You learned about lists, tuples, sets, and dictionaries. For lists, you learn how to make one, access values, update values, add values, and remove values. For tuples, you learn the exact same things minus updating values since you can't do that with tuples. For sets, you learn how to make them, how to add values to a set, and how to remove values from a set. And lastly, for dictionaries, you learned what key value pairs are, how to make a dictionary, how to access certain key value pairs, how to update values, how to add values, and how to remove values. So in this video, we covered a huge amount of information, so don't be discouraged if it doesn't all click right away. I'd highly recommend hopping into Google Colab and messing around with these different collection data types. The best way to fully understand these data types is just through trial and error, and it may take a bit of time. I'd also highly recommend, if you're struggling or forgetting how to do certain operations, to refer back to this video if you need help. Like I mentioned before, I'm also going to link a few resources in the description so that you can use these to help guide you through your learning journey. Next video will cover something incredibly important, which are loops. Take care, and I'll see you next video. Hi everyone, and welcome back to the Python for Absolute Beginners series. In this episode, we're going to cover loops. Loops basically allow us to repeat some code over and over again until we decide to stop it. Python has 2 types of loops that we'll discuss in today's episode. So I mentioned in previous episodes that variables and conditionals are like the bread and butter behind Python, but loops are what makes programming powerful. With 2 lines of code, I could print every number from 0 to 100,000. We're going to go ahead and jump right into the code this episode. The first type of loop that we have is called a for loop. And we call it that because we always start these kinds of loops with the word for. I'm going to go ahead and write out a simple for loop here, and I'll explain what each part of it does. So let's write for x in range, parentheses, and we'll do 0, 10. Then I'm going to write a colon after this to indent, and I'm just going to write print x. Okay, so now let me break this down. So if I run this code, you'll see it should outprint all the numbers from 0 to 9. So when writing a for loop, we always start it with the word for. Our goal with this loop is to print out every number between 0 and 10. So we need a variable that can represent each individual element, and that's where this x comes in. This basically means that we are representing each individual number with the variable x. So at the first iteration of the loop, x is equal to 0. And then the next iteration, it's equal to 1, then the next one it's equal to 2, and so forth. This variable name can be literally whatever we want, it just needs to follow the variable naming conventions that we discussed in episode 2. Then we have this in-range component here. And this range of numbers is the range of numbers that we're iterating over in our loop. So this first number within the range parenthesis should be the number that you want to start at, and this second number should be the one you want to end at. I'll make a quick note here that this second number is not included in the range, but it'll print everything up to that number. That's why if you see when this code is run, it prints everything up to 9, but then it doesn't actually print 10 because it doesn't include this number. So if I wanted to print everything including the number 10, I'd have to make this actually 11. If you run that, you'll see it prints that, and then 10 is added here to the end. So I'll go ahead and change this number back to a 10 here. And altogether, this statement is basically saying, let's look at every number between 0 and 10. And at every number, we're going to execute some block of code. The code that is executed at every single block depends on what is indented underneath this for statement. So in our example, we're simply printing out every single number. Note that we set x to represent each individual element, so when we write our print statement, we're just printing out x. This line containing the for statement is generally called the loop header, and whatever is indented underneath is generally called the loop body. So let's trace this loop step by step once I press run. So once I press run, we hit this first line here. So first we set up a range of numbers 0 to 10, and then we set x equal to the first number in the range. So at the very first iteration, x gets set to 0. So then we enter this block of indented code, and we just print out x, so we print out 0. Then we go back up to the loop header, and now we set x equal to 1. We enter the body again, and print out x, which is equal to 1. Then we go back up, x is equal to 2, then we print out 2, go back up, x is equal to 3, then print out 3, and so forth. And we do that up until we hit x equals 10, because 10 is the last number in this range. But because it's the last number, once it hits 10, we don't enter the body, so that's why 9 is the last number that is actually printed out in this series. In our case, we're just printing out the item in the range, but we can have as many lines as we want, and we can do literally whatever we want with inside the loop body. So above this for loop, I'm going to make a new variable, call it count. And I'm going to set this equal to 0. And basically what I want to do is at every iteration of the loop, I want to add 3 to count. So I'm going to go ahead and delete this print statement here. I'm going to write this statement here. So we're going to do count equals count plus 3. Now what this statement is essentially saying is take the existing value of count, add 3 to it, and then update it. So this is the new value of count. So what's going to happen is we start at 0 once the program starts, and then at the first iteration of the loop, we're going to add 3 to it. So count is now equal to 3. Then we're going to go to the next iteration, add 3 to it, now it's equal to 6. Go to the next iteration, add 3 more, now it's equal to 9, and so forth. And this might look a little confusing here, the fact that we have two variables of the same name in the same statement here, but just know that this is what we're updating it to, and this is the existing value of count. So we're just taking the existing value and adding 3 more to it. And what I want to do here is after the loop is done, I want to go ahead and just write a print statement and print count. And if you look at this loop, you can take a guess that the output for count should be 30, right? Because we go through this loop 10 times, and at every single time we add 3. So if I run this, you'll see it prints out 30 for count. And on a quick little side tangent here, there's actually another way you can write this line here without writing it like this, because this looks a little bit awkward, right? So if we want to just increment a number or a variable by 3, we can also just do count plus equals 3. And these lines literally mean the exact same thing. This is just a shorthand notation way of writing it. So I'm just going to go ahead and comment this out and run it again. You'll see we still get 30 because this line is basically the equivalent of this line. It's just a shorter way of writing it. It's a little more convenient, a little more widely used. So I'm going to go ahead and just delete this commented line out here so we can have it written like this. And remember when I said at the start of the video that I could print out every number from 0 to 100,000 in 2 lines of code? Well, let's do that so I can show you. So I'll go ahead and delete this count variable here, and I'll delete this print, and let's just change this back to where we had it before. So we'll do just print x. I'll go ahead and clear this output here. So I said we want to do every number from 0 to 100,000. So let's change this range to 0 to 100,000. And then let's run it and let's see what happens. And as you can see, it is literally printing out to the console every single number from 0 to 100,000. So if you were to try to do this on paper from 0 to 100,000, that would take you maybe a few hours, maybe even longer. But in Python, we can do this in about, let's say, 20 to 30 seconds, which is awesome. So I'll let this finish running here. And bam, now it's finished. We've just printed every single number from 0 to 100,000, and it did that in 32 seconds. And this is what I meant when I said loops are what makes programming powerful. Okay, so let's keep this moving. So I'm going to go ahead and clear this output here, and I'm going to clear up this code block because I want to go over a new concept. And what I want to go over now is another way that we can use for loops. So this syntax will look a little bit different, but it's going to involve what we learned about list in our last episode. So let's say we have a list and we'll call it my list. And let's just set it equal to a list that we had last episode. So we had something like oranges, we had apples, and then we had grapes. So we went over last video how to do all these different operations with lists, but we never covered how to go through all the items at once. So to iterate through all the elements of a list, we could also use a for loop, but we wouldn't use the range method. Instead, we would do something like this. We would write for x in my list, and then colon, same thing, and we just do print x. Now this looks pretty similar to our method using range, except this time we don't need to use range because we're giving it our own variable, in this case, my list. So this loop header is basically saying, we're going to look through every single item in my list, and at each iteration, we're going to set that item equal to x. So then in the body, if we just print out x, we're actually going to end up printing out all the elements of the list. So for example, when the for loop starts, it's going to set x equal to oranges. And then we print that out, and then it goes back up here, it sets x equal to apples, then it prints that out, then it goes back up one more time, sets x equal to grapes, and then it prints that out. So we can actually run this, and you'll see it prints out oranges, apples, and grapes. So it actually does not matter how long this list is. If we run a for loop like this using this method, the number of times the loop will run is equal to the number of items in the list. So in this case, we have 3 fruits, so the loop is going to run 3 times. If I replace this list with a list of ints like 1, 2, 3, 4, 5, and run this loop, it'll run 5 times because there are 5 items. We can use this exact same type of for loop with tuples, sets, and dictionaries too. All we need to do is write for, and then we make up some variable name to represent each individual element, and then we're going to write in my list, or whatever your list variable name is. Once you do that, you just type a colon to let the computer know that you want to indent, and then whatever you want to do inside the loop body, you just write here. And like I said, we can do this with lists, sets, dictionaries, and tuples. But something really interesting about Python is you can actually do this with strings too. So let's say we have another variable. Let's just call it myString, and let's set it equal to, say, bananas. And I'll clear this output here. And instead of saying for x in my list, I want to make it for x in my string. And if you do it on a string, it'll actually loop through the string and it'll print out each individual character. Oops, didn't mean to switch those there. So if I run this, you'll see it prints out each individual letter, because instead of like a list, instead of taking each individual element separated by commas, if you pass in a string to this for loop, it'll treat every individual letter as each iteration. Okay, so now with for loops, you should have a decent understanding of the 2 types of ways that we use for loops. So the first way that I showed you was to use the range method. So we would do, like we had for x in range, and we give it a range of numbers like 0 to 10, and then we would just indent, and then we would say print each individual element. So this is the first way that we did it, and that's just using a range of numbers. The second way that we can do it, I'll change this back to my list here. The second way that we can do it that I just showed you was, instead of giving it a range of numbers, to give it some variable that has multiple items in it. So that can be the collection data types we went over last episode. So list, sets, tuples, dictionaries, and like I just showed you, you can do it with strings. So these 2 ways here are pretty much the 2 ways that we're always going to use for loops in some way or another in Python. So now I want to move on to the second types of loops in Python. So I'm going to go ahead and delete this code block here, and I'll just open up a brand new one, just a clean one. So we're going to cover while loops next. So while loops are loops that run using a conditional statement. If you watched episode 3, you should be familiar with how general conditional statements work. So as long as a certain conditional statement is true, a while loop will continue to run. But as soon as it becomes false, this while loop will stop. So how do we actually write a while loop? So we would write it something like this. We would write while, then parentheses, and then inside of these parentheses, we put whatever we want our conditional statement to be. So let's write a little conditional statement inside of here. Let's write 1 less than 5. Then we're going to write a colon to let it know we're going to indent. So we're going to go into the body, and then let's just print something like LOL. So now I want you to see if you can find a problem with this loop here. I said that once a while loop reaches a false condition inside the parentheses, it's going to stop. But the issue inside of here is that 1 is always going to be less than 5 no matter what. So if we run it, this loop is going to infinitely print LOL because it's never going to stop. And I can actually show you. If I try and run it, it is literally just infinitely printing LOL and it's never going to stop. So I should actually stop it before it crashes here. And I might actually, it'll let me stop it. So as you can see, infinite loops are really, really bad. And if you let them run long enough, they could crash your program and your entire computer. So that's why I went ahead and stopped this execution here. I'm going to go ahead and clear this out too. So the important thing about while loops is making sure that they have an in condition. So you have to make sure that this conditional statement right here will eventually be false. So let's make a condition inside these parentheses here that's actually going to eventually be false. So I want to make a new variable up here. I'm going to call it x, and I'm just going to set it equal to 0 to begin with. So instead of having 1 less than 5, I'm going to replace this 1 with an x. So our conditional while loop will run as long as x is less than 5. So what we need to do here to ensure this loop ends is that we need to increment x so that it will eventually be greater than 5 so that the loop will come to a halt. So we're going to use that same operator we showed earlier with doing plus equals to increment. So we're going to do x plus equals 1. And what this is essentially going to do when we trace this is we're going to start this program, set x equal to 0, and then we're going to look at this line and say, is 0 less than 5? Yes, it is, so we're going to enter the body. And the body is just going to increment x by 1. So now x is equal to 1. Then we say, is 1 less than 5? Yes, it is, so enter the body. Set x equal to 2 now because we increment by 1 more. Is 2 less than 5? Yes, run it again and again and again until eventually x is no longer less than 5. So I'm going to actually print out x here just so you can see. And if I run this block of code, you will see it prints off 1, 2, 3, 4, 5. And actually I want to make a change to this. Instead of printing off x after I increment, I want to print out x before we increment just so you can see this process a little bit more clearly. So we run it now, and now we get 0, 1, 2, 3, 4. So like I said, we start at 0, and then this is true, so we go to the loop body, print 0, then we move x to 1. Then we go here, we print out 1, move x to 2, then we go here, print out 2, move x to 3, and so forth, until once we hit 5, so we're gonna, when we have 4 here, we print out x, and then we increment it to 5, and then we go back up to this header here, and we say, is 5 less than 5? No, it's not, so now we break the loop. And obviously this 5 here is just an arbitrary number that we just made up. If we wanted to increase the range, we could say x less than 20, and if we ran this, you'll see it prints every number pretty much from 0 to 20, but not including 20, because like I said, once x is equal to 20, we're not actually going to enter the body. So one thing I really want to note here is that if this while condition is never true in the first place, the while loop isn't going to run a single time. So I'm going to clear this output, and I'm going to change this to say x greater than 20. And if we run this, you'll see literally nothing happens. So it doesn't matter how many times we run it, nothing is going to happen. And why is that? Well, we set x equal to 0 at the very start, And then when we look at this line, we say, is 0 greater than 20? No, so we never even enter the while loop in the first place. So this while loop is never going to run, which is why if we run this code, nothing happens and it just runs instantly. But the difference is that when we have x less than 20, this initial statement at the very start of the program run is true, so that's how we enter the loop in the first place. So the biggest and most important thing about while loops in Python is being extra careful to make sure the loop cannot be infinite. So we have to make sure this conditional statement will eventually be false. If we don't and we're not careful, we'll be left with infinite loops, and those are something you never want to have in your program. So I showed you first when we had like a while 1 less than 5 in this conditional line here, but let's say we forget to increment x. If I delete this line here and forget to increment x, x is always going to be 0, so this is going to run forever. So if I run this, it should infinitely print out zeros, and I can show you like this. And it's just going to keep on printing this forever until eventually something's going to crash. So now that you've seen what to avoid with while loops, I want to do a little summary here. So I'm going to clear out this output here, and let's just make this x plus equals 1. We'll add this increment back in, so we have that there, just so it doesn't give us an error. So I want to do a little summary here between while loops and for loops. So what I showed you so far was how to use for loops in two different ways. So we did for x in range 0 to 10, and then we'll just say print x. And then what I showed you just before this was for x in my list. Let's say we have a list that we just make with oranges, apples, grapes. Then we can do that and then print x. And then this, what I just showed you just now, was how to use while loops. So these are the three main ways that you're gonna use loops in Python. So usually iterating through a range like this with a for loop, iterating through a list with a for loop, or iterating under some conditional with a while loop. So the main difference in functionality between the loops is this. So for loops are meant for when you have a list with a length that isn't going to change, or when you know exactly how many times you want to run a loop. While loops are used if you want to be a little more loose with your loops and only end once a certain condition is met. So this allows you to do a ton of things with while loops, but it also leaves you open to having infinite loops if you're not careful. So an application of while loops would be if you're programming a game, for instance. So let's say you have a Boolean called game started. If game started is true, it means the game is currently in progress. If game started is false, it means the game hasn't been started yet. So we could say while game started equals true, and then run whatever code runs the game. As soon as game started is false, meaning the game has ended, the while loop will stop and the game will stop running. So now that you should have a solid understanding of for loops and while loops, I want to go over two practice problems to solidify your understanding just a little bit more. I'm going to go ahead and delete all this here and make a fresh code block so we can start with this first practice problem here. Okay, so let's say that we have a list right now. Let's just call it mylist1, and it's going to contain the values 1, 2, 3, 4, and 5. Now, the prompt for this problem is that we want to make a new list called mylist2. I'm just going to comment this here. We want to have a new list, mylist2, that contains double all the values from mylist1. So we essentially want mylist2 to look like this. We want 2, 4, 6, 8, 10, because essentially what we're doing is just doubling each of these elements from list 1. But we want to do this without actually just initializing it like this. Because what if the values in mylist1 change? So what if we change this to like 3, 6, 9, and whatever? We want what these to reflect accurately to say, 6, 12, and then 18. So we always just want these list 2 values to be double what is in list 1. So I'll go ahead and fix these here, and I'll make these corresponding again. Okay, so first, just to start off, I want to initialize my list 2 as just an empty list, just to show that it's empty for now and that we're going to add to it later. So how would we go about solving this problem by using a loop? With all programming problems, you should first just take a second to actually break down the problem and think about how you might do this. So let's think about this from a practical perspective. So I said we want to go through each of the elements in mylist1 and double them, and then add that element to mylist2. So what we're really trying to do is loop through all the items in mylist1, at every item, multiply it by 2, and then use the .append method that we learned last episode to add this number to mylist2. So for example, at the first element of mylist1, we would just double it and then use the append method to add to mylist2. Then we go to the next element, double this, and we append to add 4, and so forth. So let's go ahead and write a loop for that. So I already showed you how to use a for loop to loop through a list. So let's write this. Let's say for item in mylist1, and then we're going to write a colon to indent. And then inside the body, what we want to do is take each individual element, which is represented by item, and then you want to multiply it by 2 and then add it to mylist2. So we can actually do that in one line, and I'll show you, and I'll go ahead and go over this and explain it if you don't understand it right away. So I'm going to write mylist2.append. And this mylist2.append you should have learned in the last episode when we went over how to add elements to a list. So this is just basically going to add an individual number to mylist2. And inside of this parentheses here, what we want to do is we want to take the element from mylist1 and then just multiply it by 2. So let's do item times 2. And the reason we do items times 2 is because item represents each individual element in mylist1. So essentially what we're doing is just taking each element, we're multiplying it by 2, and then we're just calling this append method to add it to mylist2. So if I actually go to the very bottom here and I print out mylist2, it should print out 2, 4, 6, 8, 10, because we are just doubling all of these values. And yep, you can see it prints out 2, 4, 6, 8, 10. Let's say we want to change the values in mylist1. Let's do this to 5, 10, 15, 20, and 25. And now if we run it, you'll see it prints out 10, 20, 30, 40, 50, because it is still double all of the values from mylist1. So I get that if you're brand new to Python, this code might be just a little bit overwhelming or confusing to understand at first, so don't get caught up if you don't quite understand what's going on right away. I strongly encourage you to hop into your own Google Colab notebook of your own and just mess around with this Python code. Maybe just copy and paste what I have and just try out some new things. The best way to test your understanding of a concept is to build it yourself, so try messing around with lists and for loops and just see what you can do. So I'm going to go ahead and delete all this here, and I want to move on to our second practice problem. So I'm going to delete this cell, open up a new one, and our second practice problem is going to contain while loops. So let's say we want to make a fun little mini game. We want to build a super basic number guessing game. We'll have a number between 0 and 10 that is the correct number, and we'll prompt the user to take a guess. If the guess is correct, the program will stop. If the guess is incorrect, the program will keep running. Let's build the guessing functionality first. So I'm going to start off by making a variable name called correct number. So let's say correct number, and we said we wanted it to be something 0 through 10. Let's just set it equal to 7 to start off. And this will represent the number that we need to guess correctly. So the correct guess would be 7. So let's also make a variable called user input. And this is going to represent whatever the user inputs into the keyboard. So this is going to be basically what their guess is. So we're going to do user input equals input. Let's just type, please enter a number from 0 to 10. And if you remember in episode 3, we used this input function before. And if you're not familiar, what it basically does is just prompts the user with some text. So we say, please create a number from 0 to 10, and then it opens up a little text box, and the user can type something in and then press enter. And just like last time, I'm going to wrap this whole thing in a int parentheses here, so that we can ensure that whatever the user enters is always going to be an integer. So far we have correct number, which is just 7, and then we're storing our user number in user input. So now what? So now we need to write a conditional statement that checks if the number the user typed, in other words, user input, matches the correct number, which is just correct number variable. So let's write a conditional. Let's write if user input equals correct number. And then inside of this if statement, I just want to print, let's say you guessed the number correctly. But what if the user guesses incorrectly? For that, we'll use an else statement. So let's say else, and then we'll just print, let's say you did not guess correctly. So now let's just run this program so I can show you kind of how this works. So I'm going to run it and it's going to prompt us. It's going to say, please enter a number from 0 to 10. So we know that the correct number is 7. So let's enter something intentionally wrong like 5. So when we enter 5, what's going to happen is we hit this if statement. We're going to say, is 5 equal to 7? Nope. So we enter the else statement and it's going to print off, you did not guess correctly. So we can see that our conditional here is working just fine. Let's test actually guessing the correct number now. Let's say we input 7, and yep, it'll say you guessed the number correctly. So we can tell our conditional works just fine, but this isn't entirely what we want. Remember that we said that we wanted the program to keep running until the correct number is guessed. Right now, we'll only run the program one time because we don't have any kind of loop or anything. So this is where a while loop would come in. So we know that a while loop has to run based on a conditional statement that'll either be true or false. So let's make some space up here, and I'm going to make a new Boolean. I'm just going to call it gameActive and set it equal to true. And what this is going to mean is that if this value is true, if gameActive is true, then that means that the game is still going on. If it is false, that will mean the game has stopped. In other words, if the user guesses the incorrect number, this variable should stay true. If the user guesses the correct number, we'll want to change this Boolean to false so that the game ends. So let's go ahead and write a while loop now. So I'm going to actually move this up. I'm going to cut and paste this up here at the top. And inside of our loop, we're going to want to have all of these lines of code because we're going to want to say at each iteration, the user will take a guess and then we'll check, is it correct or is it not correct? And we don't want to have these two lines inside the loop because these want to be initialized before the loop starts. So let's just go ahead. Let's fix some of the spacing here. And let's just write a while loop. So we want to say while game active. And this is essentially the same as saying while game active equals true. But because it's a Boolean, we can just write it like this. And what we want to do actually is we want to indent all of this code inside of the while loop because we want it to run at every single iteration. So I'm going to highlight all of this and then press tab. So now we have one thing left to add. So if the user guesses the correct number, which is represented by this if statement, we're going to need to add a line that updates gameActive to be false. Because we said if the user guesses the correct number, we want to end the game. So we need to break the while loop. So under this print line, I'm just going to make a line here that says gameActive equals false. And make sure again that we're capitalizing these F's and T's on false and true. So once this line is changed to false, we will not continue to run this loop because the while loop is only going to run while gameActive is true. And if the guess is incorrect, we don't need to change gameActive at all because it'll still be true. So let's run this code a few times. So we press run and it prompts us for a number from 0 to 10. So let's do an incorrect guess. Let's say 2. Oh, well, we didn't guess correctly, so it's going to prompt us again. Let's say we put 9. And that was another correct or incorrect guess, sorry, so it prompts us again. Let's say 6. That's incorrect, so it keeps prompting us. And then once we input 7, which is the correct number, it should say you guessed the number correctly, and then the program halts, so we don't get prompted again for input. And let's actually try this again. Let's change the correct number. Let's say correct number this time is going to be 4. So let's rerun this. And let's just guess some incorrect numbers first. Let's get 7. That's incorrect, so it prompts us again. Let's do 9. Incorrect, so it prompts us again. Let's do 5. Incorrect, so it prompts us again. And then let's finally do 4. And then it prints out, you guessed the number correctly, and the program ends. So just like with the for loop section and the other practice problem, this practice problem might look a bit daunting if you're not super familiar with loops just yet. And obviously it takes time, so I'd highly encourage you to go into your own Google Colab notebook and just copy and paste this code and just mess around with loops as much as you want. Just try with while loops, try with for loops, and just see what you can do with Python. So hopefully now you should have a decent understanding of how loops work in Python. So in this video, we went over for loops and while loops. You learned how to use for loops to iterate through a certain set of numbers and also through a list. Then you learned how to use while loops to keep running as long as a certain condition is met. Then we went over 2 practice problems to solidify your understanding of each type of loop. With your knowledge so far of loops, conditionals, variables, and collection data types, you should actually now be able to build almost any Python program that you want, as you now know the bread and butter behind Python functionality. In the next 2 episodes, though, we'll cover functions and classes, which will both make your life a ton easier when building your own programs. So take care, everyone, and I'll see you in the next video. Hi, everyone, and welcome back to the Python for Absolute Beginner series. In this episode, we're going to cover something called functions. Although you may not recognize what functions are just yet, we've actually used them a ton in the past couple of episodes. If you recall, to print something out, we would just type print, then parentheses, and then type whatever we wanted to within inside these parentheses. What about when we have, let's say, a variable, let's say x equals 5, and we want to check the type of it when we write type of x? Or how about, like in the last episode, when we use the input function like this to prompt the user to enter some number? These 3 lines of code, this print statement, this type statement, and this input statement, are all what we call functions. So functions are essentially blocks of code that can be called, or in other words, run, by typing their name followed by parentheses. These 3 functions here that we've used are all built-in functions in Python, meaning they simply come with the Python programming language. A function call is when we type the name of the function followed by parentheses. So this line up here would be calling the print function, this line right here is calling the type function, and this line right here is calling the input function. Functions can take in what are called arguments, and these are what we put inside the parentheses of a function call. So for example, this print function takes in one argument, which is a string, in this case, hello world. Even though it can be any number of words long, it's still only one argument because it's one string. We only pass in one value or variable to type, meaning that it also has only one argument, and the same is true for input. It just has a string as its one argument. But there are functions where you need to pass in more than one argument. One example would be the pow function. This function is written something like this. We would write pow, let's say 5, 2, and it basically returns us 5 to the power of 2. In this example, we're passing in 2 arguments and they're both ints. Anytime you pass in more than one argument, you separate the arguments with a comma. So these built-in functions are great and can hopefully give you an idea of how functions work. But this isn't necessarily why functions are important in Python. Functions are important because in Python you can write your own functions, and the point of writing your own functions is to not have to repeat code over and over again. So let's say that for whatever reason we want to print out a greeting message that has a couple of different print lines in it. So I'm going to go ahead and delete this and start fresh. Let's say we want to have a line that says print, let's just say hello user. And you want to have another line that's another print statement, and we're going to say, how are you doing today? And then we'll have another one that'll say, it is very nice outside this afternoon. And then we'll have one more that'll say, do you have any plans for the day? So what if we wanted to run this code, let's say 3 times? It would be super annoying if every time that we wanted to run it, we had to copy and paste it like this. So we don't want to have something like this, where if we run it 3 times, we literally copy and paste it 3 times. The solution to this problem would instead to write a function, maybe just call it greeting, that had these lines of code inside of it. Then, whenever we wanted to display these greeting lines, we would just call the greeting function once, and it would do it all for us. So let's actually do that. So I'm going to go to the very top of this page here, and I'm going to write a function. So first we write def, followed by a space, and then our function name. So we'll just do greeting, and then parentheses, and then just like we did for conditionals and loops, we'll type a colon and indent to let the computer know that we're now inside this function. And inside this function now, I'm just going to cut and paste this code. I'll make sure to re-indent this so it looks something like this. So when writing functions in Python, we always start them with def. And def is just short for define, because the actual code of the function is called the definition of the function. So all of this here is just the function definition. So then we write the name of our function, whatever we want it to be, and then followed by parentheses. And note that we have to have parentheses right after our function name, even if we don't put anything inside them. And I'll explain what these parentheses actually do in just a moment. Then, just like the loops and conditionals, we put a colon so we know that the following lines are going to be indented. So note that this function doesn't actually run any of this code until we call it. So because we just have this function definition here, if we run this block here, we'll see that nothing actually happens. So we'll give it a second, and you'll see the code is complete and it doesn't print out anything. And that's because I'm just defining this function, I'm not actually calling it. So let's actually call this function now. So to call it, we would use the same type of syntax that we did when calling any other function. So below here, I'm just going to type greeting with parentheses. And again, we need parentheses when calling a function, so make a note to never forget these. Putting the parentheses right after the function name is how the computer knows that we're referring to a function. Let's run this code chunk, and then now you'll see that it prints out all these lines of code. And now, anytime we want to output these lines of code, we can just call the greeting function. So let's test this a few more times. Let's clear this output here, and I'm going to call it, let's say 2 more times. And I'll just write greeting again here, and then greeting again here. And if you run it this time, it's kind of cluttered here, but you can see it printed this off 3 times. So here's the first time, here's the second time, and here is the third time. So pretty neat, huh? This allows us to avoid having to duplicate all of our code over and over again. We just write it once inside of a function, and then whenever we want to use it, we can simply just call the function. So just to quickly reiterate what we just learned, functions are some block of code like this that you can define on your own. Whenever you want to use that code, you can just call it by typing the function name and parentheses. Where you actually write the function itself, right here, is called the function definition, hence why we use the keyword def when defining it. When you actually run the function code like this is called the function call. So let's move on to arguments now. So I mentioned with our built-in functions like print, when we would pass in arguments, we would do something like this, right? Inside the parentheses, we would write hello world. And this hello world string here represents an argument that we're passing in. So what if we want our own self-defined functions to have arguments? To add that, we add these arguments within the parentheses in the actual function definition and inside the function call. So inside of our function definition, let's just make an argument, and let's call it arg1, and that'll just be short for argument 1. And then I'm going to change this body here. I'm going to delete most of this. I'll actually delete this too, clear this output. So inside of here, I actually just want to print arg1. And then I want to call this greeting function. So I'm going to call greeting, and I'm going to pass in hello world. And then if we run this code now, you'll see that it prints out hello world. So let's say I want to call it again. Let's do another greeting call, and let's just pass in hello YouTube. And if we run it again, you'll see it prints out both hello world and hello YouTube. So here's what's happening. So every time that we call this function, we pass in one argument, in this instance, hello world, and this argument is represented by arg1 in the function body. So when we call greeting, I can pass in whatever argument I want, and our function will print it out. The number of arguments in your function call, like this, should always be equal to the number of arguments in your function definition here. So our function definition has one argument, arg1, so our function call needs to only have one argument, no more, no less. If I change our definition here to have 2 arguments, let's say arg1 and arg2, and I try to run this, I'm actually going to get an error here because we're only passing in 1 argument when the definition is expecting 2. And let's try the reverse. Let's make this have only 1 argument, but I'm going to pass in 2 arguments to the call. And that will also give me an error because the number of arguments in the function definition is not equal to the number of arguments in the function call. So long story short, always match the number of arguments in the definition with the number of arguments in the call. So I'll go ahead and delete this here so we can fix it, run it again, and you'll see everything is back to normal. If we have multiple arguments, the order of the arguments is extremely important. So let's say in our greeting function, we now have 3 arguments. Let's have arg1, arg2, and arg3. And inside of this print statement, I'm going to change it a little bit here. I'm going to write arg1 is equal to, and I'll tell you what this means in just a second, how I'm doing this little print statement here. I'll write arg2 is equal to arg2, and then we're going to print arg3 is equal to, arg3. So basically, the way I'm writing these print statements here, you might notice there's a comma here, which is a little bit confusing because we just said print statements have one argument, but essentially what we're doing here is we're just combining a string and a variable in the same sentence so that we can print them out together, and I'll show you what it outputs in just a second. So now in our function call, in our function definition, we have 3 arguments. So in our function call, we need to pass in 3 arguments. So let's delete this. And let's say we want to pass in 3 numbers. Let's just say 5, 7, and 3. And if we run this code, you'll see that it says arg1 is equal to 5, arg2 is equal to 7, and arg3 is equal to 3. And this order happens because when we call the function, the order of arguments matters. The first value passed in our case 5, is going to get assigned to arg1. The second one passed in, which is 7, is going to get assigned to arg2. The third one passed in arg3 is going to get assigned to arg3. So the order matches up exactly, and it's always going to be that way. So if I wanted, let's say 7 to be arg1, I would have to change the order to have 7 here and 5 here because it translates directly the order. So 1, 2, 3, and then 1, 2, 3. And if we print it out here, you'll see it now says arg1 is equal to 7, arg2 is equal to 5, and arg3 is equal to 3. And while we're here, now is a super good time to mention something important. So the reason I wrote this function at the top of the page and not the bottom or anywhere else is because a function has to be defined before it is called. So remember that Python is pretty strict about running its code in order, so we need to have function definitions at the top of the page. If I call a function before it's defined, let's say I have something up here and I'm calling greeting up at the top, let's just pass in 6, 5, 2, and I try to run it, I'm going to get an error because at this point, the code doesn't know that this function actually exists yet because we haven't reached that line. So when we call this function greeting, it's going to throw an error. So just make sure that you always define functions at the top of the page so you can avoid errors, and it'll save you a lot of time when troubleshooting. So the last important thing that I want to go over with functions is return values. So right now in our function, all we're doing is basically writing a couple of different print statements. But what if we actually wanted to do some math or some other operations inside a function and then assign that to a variable somewhere else in our code? And that's where our return statement comes in. So I'm going to go ahead and delete this function. Actually, I'm going to delete this whole code block here. I'm going to make a new code block so we can start fresh. And I want a new scenario here. So let's say I want a function that will return the square of a number. So if I pass in 3, let's say to the function, it should give me back 9. If I pass in 4, the function should give me back 16. And if I pass in 5, for instance, the function should give me back 25, and so forth. So let's write a function called square number. So I'm going to write def, let's say square number, and then I'll write parentheses. And inside of these, I'm just going to pass in one argument, and I'll just call it x. And then I'll write the colon here, indent. And to get the square of a number, we know that we need to multiply a number by itself. So I'm going to take our argument x and just multiply it by itself. So I'm just going to write x times x. Now we need some way to get this result back to our code whenever it is called. And that's where we write a return statement. So before this x times x here, I'm going to write return. So I'll show you how this actually works now. So let's actually call this function down here. Let's write square number, and then we're going to pass in 5. And if we run this, you'll see that it outputs 25. So what's happening is we call this square number function here, right? And then we pass in 5 as an argument. Now, when you look at the function definition, we're basically just passing in 5 to this x argument, and then we're just returning 5 times 5. So when we call this, that's why it outputs 25. So let's actually make a variable now so we can store this. Let's make a new one called my variable, and let's set it equal to this. And then now if we do it like this, it's not going to print anything out because we're just doing a variable assignment. But now we're going to store the value 25 inside of my var. So now if we just print my var, it should print out 25. The important thing to know here is that this return statement basically specifies that we're just storing x times x within the function call. So whenever we call square number 5, this is now storing the value 25. If we were to call square number 4, this function call would be now storing the value 16. So this return statement basically just tells us what we're going to actually store in the results of the function call when we're actually calling it. Let's do another quick example so you can kind of get the idea of how this return statement works. So I'm going to go ahead and clear this output and delete all this. And I want to write another function called sum3values. So I'm going to write def, let's say sum3values, and then parentheses, and then we're just going to pass in, let's say 3 arguments. Let's say x, y, and z, and that's because we're going to be summing 3 values together, so we're going to pass in 3 arguments. Then I'm just going to do a colon, indent, and inside of here, I'm just going to write return x plus y plus z. Then down here, let's actually call this function. So we just defined sum3values. Now I want to call it. So we type the name and then parentheses. And then let's say we want to pass in, let's just do 5, 5, and 5. And if we run this, you'll see that it outputs 15. So we can return literally whatever we want from a function, and this return value is always going to get stored in the function call. So if we want to access the return value, we can grab it by doing this. And one important note here is that we should only ever have one return statement in a function. So we don't want to have, like, say, return x plus z. Now, if we do this, we actually won't get an error. You'll see it still outputs 15, because basically it's going to return at the very first return line that it sees. So it's just going to return here, and it's going to completely ignore this line. But the general statement of truth for writing functions is that we don't want to have multiple return statements. We just want to have one, because we can only ever return one value from a return statement. So at this point, I want to summarize what we've done so far. So far, you've learned what some of the built-in Python functions are, how we can make our own functions to prevent repeated code, how we can call our own functions, and how we can return values from these functions. To solidify your understanding a bit more, let's do a practice problem. For this practice problem, let's say we have a list that has all ints. So I'm going to go ahead and delete this, make a new code block here. So we're going to have a list that has all ints. So let's say we'll just call it my list, and let's just do 5, 2, 9, and 6. And our goal is to write a function that can find the highest number out of this list. If our function works correctly, it should end up outputting 9, because 9 is the highest number out of this list. So how can we solve this? We'll want to have a variable called max, or maximum, that can store the maximum value. At the end of our function logic, we'll want to return that max. So how do we find this max? Well, we can loop through all these numbers using a for loop and then find our max that way. So let's get to writing. Let's make some room up here, and we'll go ahead and define our function. So let's write def, and we'll just call this function find max, and we're going to pass in one argument, let's say list var, and this will just be short for list variable. And then we'll do the colon and indent. And I said that we want to have a max variable that we can return at the very end. So let's make a new variable called maximum, and we'll just say start it at 0 for the sake of this code. So then we want to use a for loop that we learned last episode. So our list is represented by the argument list var. So let's loop through that list. So let's say for number in list var. We'll just do the indentation here. And then what do we want to do now? So at every item in this list, what do we actually need to accomplish? So we want to compare the current value in the list to our maximum value. If the current value in the list is greater than the maximum, then this current value should become the new maximum. And we can write that exactly like this. So I'll write an if statement, and we'll say if number is greater than maximum, and like I said, number represents each individual element in this list variable. So that would represent like a 5 or a 2 or a 9 or a 6. So if the number is greater than the existing maximum, then what do? Then we should update the maximum to equal this number. If the current number is not greater than the maximum, we can keep the current maximum where it's at, so we don't need to do anything and we can continue the loop. The last thing we need to do is to return the maximum. So let's make a new line here, and let's write return maximum. And notice how I make this return statement at the same indentation level as the function. So we want to make sure that this return is not inside the if or inside the for, because if it was like this, then we're doing something entirely different because it's inside the if statement. And if we're doing it like this, we're doing something entirely different because it's inside the for loop. So what we want to do is have it outside here at the main level of indentation of the rest of the function. So now let's try calling this function and actually testing it out. So we have this new variable down here that we set earlier, myList, and we set it equal to 5, 2, 9, and 6. So let's just make, let's say we're going to just call this here, and then we're going to do find max, and we're going to pass in our list. And if we run it, you'll see that it outputs 9. So we pass in this list, in other words 5, 2, 9, 6, to this function here. This function runs all of its logic and it returns the number that it finds that is represented as the maximum. Let's try changing this list around to different numbers just to test out this functionality. Let's do 4, 3, 2, and 1. If we run it, you'll see the maximum is 4. Let's do 25, 10, 27, 50. And if you run it, you'll see it outputs 50. And we'll do it one more. We'll just do, let's say 7, 15, 12, and 6. And you'll see it outputs 15. Now I should quickly note that this function is actually pretty much completely obsolete because there's actually a built-in function in Python called max that does this exact same thing. So we actually don't need to actually really write this out, but I just wanted to kind of give you this as an example so you can see how this worked. So like the actual built-in Python function, we would do max of my list like this, and it would still print out 15 because it runs pretty much the exact same logic. I just wanted to do this so I could show you guys kind of how the code was working with inside the function. So I'll go ahead and change this call back to our function here, find max. And then what I really want to do now is just kind of show you how this function works if you're having trouble maybe understanding it. So this might look super daunting because we have a whole lot of indentation going on kind of happening here all at once. So if it confuses you, just try and break it down line by line and I'll go ahead and follow along with that. So first with this line, we're just defining a function and we're calling it find max. And here we're just passing in one argument, which is list var. So then we're creating a variable called maximum. And for the sake of this code, we're just setting it equal to 0. And this maximum is going to be what we want to return at the very end of the function. Then we take the argument that we have, list var, and we loop through every single item in that list. And at each item, we check. We say, hey, is this current number greater than the existing maximum? If it is, let's update the maximum to be this new number. And then if it's not, nothing else happens, so we go to the next iteration of the loop. And this keeps going and going and going until it finds the maximum and it stores it, and then it returns the maximum. And then when we call this find max function, it stores the maximum in this function call. So now let's actually trace this step by step using the list that we pass in. So when we call find max on my list, here's what happens. So we look at the function definition and we start with maximum equals 0. So we're making a new variable maximum and setting it equal to 0. And then we're going to start to loop through all of the items in the list that we pass in as an argument. So in this case, the list that we pass in as list var was 7, 5, 12, and 6. So the start of this for loop is going to start at the number 7. So we say, is 7 greater than 0? Yes, it is. So we're going to set the maximum equal to 7. Then we go back to this for loop and we say, is 15 greater than 7? Because 7 is the new maximum. 15 is greater than 7, so we update the maximum to equal 15. We go back to the for loop and then we say, is 12 greater than 15? Because 15 is now the new maximum. We say no, 12 is not greater than 15, so we just continue. And then we hit 6, we say is 6 greater than 15? No, it isn't, so we just continue. But now the for loop is done, so we unindent and go back to this return maximum, and 15 is in maximum, so that's what we return. So that's why when we run this call, find max my list, we get 15. And just like I mentioned before, it should be a general rule of thumb that you always have the return statement at the same indentation level as the rest of the function and not inside another for statement or an if statement. Because for instance, if I had it like this and I tried to run it, it would return 7, which is not correct. And if I did it like this, it would also return 7, which is not correct. So we need to make sure it's outside of any for loop or while loop or conditional statement. and it's just at the same indentation level as the rest of the function, and it'll run properly. Hopefully now you should have a decent understanding of how functions work in Python. We learned built-in functions, how to make your own functions, how we can call our own functions, how we can use arguments, and how we can return values from our functions. Like always, I'd strongly encourage you to hop into your own Google Colab notebook and just mess around with these, because the absolute best way to learn is by trying it yourself. Our next video, episode 7, will be the last primary video in the series, and that's where we'll cover classes. After that, we'll do one wrap-up video that contains some summaries in the outlook moving forward. Take care everyone, and I'll see you in the next video. Hi everyone, and welcome back to the Python for Absolute Beginners series. In this episode, we're going to cover classes and objects. Classes and objects are definitely an intermediate level topic, but I wanted to take an episode to go over them because you'll see them used all the time in Python. There's quite a bit to unpack with classes, so I'm not going to go over every single aspect of them, but rather I'll go over everything you need to get started. In programming, we have two main types of programming styles. The first one is called functional programming, and functional programming is all about using functions, which we learned last episode, to organize and run all of our programs. The second one is called object-oriented programming, sometimes called OOP for short, and this type of programming style uses what are called classes and objects to organize and run all of our programs. These are two very distinct styles of programming, and they look very different. Functional programming came first, and then object-oriented programming came a little bit later. There are pros and cons to each of them. If you continue on your programming journey, you'll find that some people feel very passionately about one style or the other, and it's kind of like a civil war in the programming world. Many programming languages support both functional programming and object-oriented programming, but some languages require you to write in a particular style. We're here to talk about Python though, and here's what you need to know. Python uses both object-oriented programming and functional programming, but I would argue it's a little bit more object-oriented than functional. This means that you'll have to know how to use classes and objects in Python because chances are you'll see classes and objects pop up all the time. So what actually are classes? Classes in Python and in most other programming languages are used as a way to organize data and instantiate what are called objects. A class is basically a user-defined blueprint for creating instances of that class, which we call objects. For example, we could have a class called car. Then we could create a 2016 Dodge Charger from this class, and we would call this Dodge Charger an object. Then we could create another car, a 2018 Honda Civic, and also call that an object of the car class. Another example would be making a class called dog. We could have a beagle with the name Mario, and he would be an object of this dog class. We could also have a dog named Coco as an object of this dog class as well. The point is, a class is a generic way of making a blueprint for something. Then we can use this blueprint to make objects of this class. So let me show you how you can actually do it. So we'll hop over to our Google Colab notebook here. So the first example I used for a class was the idea of having a car class. So let's write out an actual car class in Python. So to begin writing a class in Python, we use the convenient class keyword like this. Then we write whatever we want the class name to be. So in our case, we'll name this class car. And note that with classes in Python, it's a good practice to always capitalize the first letter of the class. This helps differentiate between functions from a user perspective, since functions should always start with a lowercase letter. So after this car word, we'll type a colon and indent so we know that we're now inside of this class. Because this is a class and not a function, we don't have to worry about always typing parentheses after the class name. So what are some descriptive qualities that we could use to describe a car? Typically we might say we have like a make, model, color, and a year, for instance. So I'm going to make a comment with this. I'm going to say, what do we want in a car? And then let's just write what I just said. So we'll have make, we'll have model, we'll have color, and we will have year. Okay, so the question is, how do we actually implement these qualities for our class so that we can create some car objects? In Python, we do that through what's called the initialization function. And what this function does is sets all the attributes that we want for our class. And here's how we write this function. Like all functions, we're going to start it with the keyword def. And then we're going to type underscore underscore init underscore underscore and then parentheses. Make sure it looks exactly like this, because if it's not written like this, it's not going to accomplish what we're trying to do. Then inside the parentheses, we're going to write all the attributes that we want to pass in. We said we wanted to have make, model, color, and year. But we need to add one more argument, and this one is extremely important. Our very first argument, no matter what class we make or what we're doing, should always be named self. I'm going to add this here, and I'll explain why we need this. We said that the whole point of classes was to make objects of this class, which are just instances of this class. This self argument right here basically represents the current object that we are talking about. So I'm going to write a few more lines of code, and hopefully you'll start to see what I mean by that. So let's write a colon here, and we're going to go ahead and indent under this function to let it know we're now inside of the init function. And then I'm going to write all of these attribute assignments out, and then I'll explain what they mean and how they're working in just a second. So first, I'm going to write self.make equals make, self.model equals model, self.color equals color, and self.year equals year. Now, at first, you might be thinking, this looks like it makes no sense. Like, what are we doing here? And don't worry, you're not alone, because most beginners think that. So let me break down what we actually have here. And while we're here, I'm going to go ahead and just hide this header here so we have a little bit more room. I'll fix this typo right here. Okay, so when we create new objects of a class, this init function that we have defined right here will always be called automatically. And it'll look at whatever values we passed in as the make, model, color, and the year. Now, I said that self represents the current object that we are talking about. So what we're saying with this line here is that this object's make is equal to the make that we pass in as an argument. What this line is saying here is that this object's model is equal to the model that we pass in as an argument. And you get the idea with color. We are assigning this object's color to the color that we pass in, and we are assigning this object's year to the year that we pass in as well. And whenever we're creating objects and making these attributes here, we're going to use this dot operator, which is just the dot or the period on the keyboard. And I'll explain what that means here in just a second, but just know for now that this is how we actually initialize all the attributes for a class that we want. So let's create an actual object of this class so I can better explain what all this is doing and actually show you how it works. So I'm going to go ahead and get out of here. I'm going to unindent from the function. I'm going to unindent from the class too, so we're back at the main level of indentation. And to create an object of a class, we would create a variable similar to any other data type. So let's make a new variable. Let's call it myCarObject. And we're going to set it equal to car, parentheses. And this is where we pass in whatever qualities we want this car object to have. So I want this car to have a make, let's say Chevrolet. Let's say I want the model to be a Malibu. Let's say I want the color to be red. And the year will be 2008. So here's what actually happens when I write this line here. So I pass in Chevrolet as the first argument, Malibu as the second, red as the third, and 2008 as the fourth. So the computer sees that we're creating a new car object because we have this car keyword here, which is just the name of our class. So what it does is it looks inside this car class and it's going to immediately and automatically call this init function. The init function is going to take in the arguments that we specified here. So Chevrolet is going to be assigned to make, Malibu is going to be assigned to model, red is going to be assigned to color, and 2008 is going to be assigned to year. So these values here in the parentheses, all of the values except for self, represent the arguments that we pass in when creating our object like this. Then inside of our actual init function with these lines, we are setting our actual object attributes to equal these arguments. So we're saying this object's make is equal to the make that we pass in, this object's model is equal to the model that we pass in, and so forth. Where this whole thing may confuse you or throw you for a loop is when we have this self argument here. Because last episode I said that when calling a function we need to pass in exactly as many arguments as are in the function definition. Except here, this init function takes in 5 arguments, but when we're actually calling it, we're only passing in 4 arguments. So having this self argument here kind of throws things for a loop because it causes the function definition to always have one more argument than the actual function call. So we can ignore the self argument when creating new objects. As you noticed here, we're not actually referencing any self argument. Just know that this self argument is used inside the class to refer to an object of the class, like with here, with the attributes. So you're not actually required to name this argument self, but self is the standard and it's what you're going to see everywhere, so you might as well just use it. The only requirement is that it needs to be passed in as the first argument. Let's make a few more cars now so you can get a better understanding of classes and objects. So I'm going to rename my car object to instead just say, let's just name it car1. And I'm going to copy and paste this line twice, just so we can have some more cars here. I'm going to make car2 and I'm going to make car3. So for car2, let's make this a Ford. Let's give it a model of Fusion. Let's say the color is black, and we'll make it like a, let's say 2016. And then for car 3, we'll name this Hyundai, and we'll do an Elantra, and we'll say that's, let's just say gray, and we'll give it a year of 2020. And now inside this init function, I'm actually going to write a print statement here. I'm just going to write print, we have just made a new object, to show you something here. Because every time we create an object, this init function will be run. So if down here we are creating 3 cars, we should see that we printed out this line 3 times. So if I go ahead and run this code here, you'll see it will print out we have just made a new object and it'll do it 3 times. So now that we've gone over how these objects are created, let's see what we can actually do with some of these objects. I'm going to go ahead and delete this print line here since I already showed you with this output. And so we know every car now has a make, model, color, and year because we define those attributes within the init function. So to actually access properties of an object that's already created, we use what's called the dot operator, which literally just means the dot or period on your keyboard. So let's say we want to access, let's say the make of car2. To do that, we would just type car2.make, and it's super simple just like that. If we wanted to access the model, we would just do car2.model. So the general syntax is just the object name followed by a period followed by the attribute that you are trying to access. So let's actually wrap this in a print statement here. And if you run this and we see, let's actually change this back to make here. If we run, we print car2.make, you'll see it prints out Ford. And this makes sense, right? Because when we created our car2 variable here, we passed in Ford as the make argument. Let's try some more things. Let's print out car2.color. If we do car2.color, it should print out black. Let's do car1. Let's say car1.model, and you'll see it'll print out Malibu. Let's say we want to do car1.year, and it would print out 2008. So to grab any attribute of any object that we want, we always just type the object name, followed by a dot, followed by the attribute that we're actually trying to access. But you have to make sure the attribute actually exists though, because if it doesn't, and you try to use the dot operator, you'll get an error. So in our init function, we only define make, model, color, and year. So let's say for whatever reason, I try and access car1.trim. Now if I try and run this, I'm going to get an error that says car object has no attribute trim, and that's because we didn't define trim anywhere within this class, so the computer gets confused here, and hence why it throws an error. So I'm just going to go ahead and clear this output here, and I'm going to go ahead and just delete this line. So in addition to just viewing attributes using the dot operator, we can actually also use the dot operator to change and update attributes as we need to. So when we created car1, we initialized it with the color red. So what if we had a change of heart later in the program and decided that we want to change the color of car1 to, let's say, white? And we would just use the dot operator in the exact same way, and it'd be super simple. So we would do car1.color equals white, for instance. And we would just assign car1.color to whatever new variable we want it to be, in this case, white. So now if we actually do print car1.color, car1.color here, you'll see it outputs white. One of the really neat things about classes in Python is that in addition to storing values like make, model, color, and year, we can also store functions inside of classes. So let's unindent and get out of here, and let's make another function. Let's just call it print make. And just like any other function that we have to write within our class, we're going to pass in the first argument as self. And we're going to type a colon, indent here, and inside of here, I'm just going to type print. Let's say the make of this object is a, then we'll do this notation here. We'll do self.make. So now that we wrote this function here, every single car object we've created is now going to have access to this print make function. So let's actually call it. So let's clear this out here. Let's delete this line. And to call a function, we use the dot operator just like we would when accessing attributes, but we have to be sure to add parentheses at the end so the computer knows that it's a function. So we'll go ahead and type car1.printMake, and again, make sure we're adding parentheses here. And then let's run this code here. And you'll see it prints out the make of this object is a Chevrolet. So why does it print this out? So we're calling printMake using car1. So we referenced this printMake function up here. So what does this self represent when we're calling it using car1? We said that self represents the particular object that we're talking about. So when we call car1.printMake, self is equal to car1. So really, when we're typing this line here, we're saying print, the make of this object is a, and then we're typing car1.make because self is equal to car1 since we're calling it using car1 in this instance. If, for instance, down here, we change this to car3.printMake, now we are calling this printMake function with car3, so if we run it, it'll say the make of this object is a Hyundai. A lot of times you'll see what are called getter and setter functions in Python classes. So getter functions just return a particular attribute of an object, and it's just a fancier way of using the dot operator like we've already done to get object attributes. So we would write a getter function like this. We would say def, let's say getMake, and we would just pass in self as an argument since we always need that. And then inside of the function, we would just type return self.make. When this function is called, it's literally just going to return the make of whatever object is calling it. So now if I were to go down here, delete this line, and I were just to write car1.getMake with parentheses to let it know that it's a function, and if I ran it, it would say that it's a Chevrolet. If I change this to car2.getMake, you'll see it'll output Ford, and if I change it to car3.getMake, you'll see it'll output Hyundai. A setter function is similar to a getter function, except it is used to update a variable instead of just retrieving it. So to write a setter function for make, we'd write another function down here. Let's call it def setMake, and then for our arguments, we're just going to pass in self and make. And then we're going to do a colon to indent here. And what we're going to do here is just self.make equals make. And you'll notice that this syntax here looks pretty similar to the syntax that we have in our init function here. So when we call this setMake function, we want to pass in the make as an argument, and this make is going to represent the value that we want to update to. And then, of course, like always, we have the self. And then inside of this, we're saying this object's make is now equal to the make that we're passing in as an argument. So for instance, to use this function, I'm going to go down here, and I'm just going to write car1.setMake, and we're going to set it to a Toyota. And I'll clear this output here. I'm going to change this one to car1. So what's happening is we first initialize car1 and it has the make of Chevrolet. And then with this setMake function, we're updating it to Toyota. And then this getMake function should print it out. So if we run it, you'll see that it prints out Toyota here. So basically anytime that you want to write a getter function like this, you just need to pass in self as an argument and then pass in whatever attribute you want to update. And then inside of here, you just want to write self dot whatever that attribute is equals whatever that attribute is. And like I said, you certainly don't need these getter and setter functions here that I just wrote, because I already showed you how to get attributes and update attributes just using the dot operator, but you may see them at some point or want to use them to make your code look a little fancier. I want to go ahead and end this video here. We've covered a huge amount of information, and I don't want to keep throwing more things at you for right now. There's a decent amount more to cover in regards to classes, but this is a beginner course, and I just wanted to give you the basics so that you could at least have an understanding of what classes are and how to make objects of these classes. If you made it to the end of this video, I want you to give yourself a pat on the back. Classes are not an easy topic to understand for beginners, and like I said, classes are definitely more of an intermediate skill level topic anyways. Please do not be discouraged if some of this doesn't make sense to you just yet. Take some time to try out classes on your own using this video as a guide. Like always, I'll drop some resources in the description that should hopefully help you out a bit. At this point, you have pretty much all the knowledge you need to get started with building some of your very own Python programs. The next video will be the last video in the series, and in that video, I'll go over a bunch of small, miscellaneous things that may not have fit neatly into the previous videos. I'll also talk more about moving forward with Python and how you can begin creating your own projects. Take care, everyone, and I'll see you in the last episode. Hi, everyone, and welcome back to the final episode in the Python for Absolute Beginners series. I hope you've been able to learn a lot during this series, and if you've made it this far, I really commend you, because learning programming from zero can be pretty difficult. In the last couple of videos, we've covered pretty much all the basics that you'll need to know to get started in Python. Each of the videos was reserved for one or more core concepts, but there's a couple of things here and there that didn't fit neatly into the core concepts that are still really important to know. I want to take this video to cover concepts that may have been overlooked in previous videos and reiterate some key concepts that will definitely help you out. At the end, I'm going to go over how you can keep moving forward in Python and what your next couple of steps should be. I want to start off by reiterating how to use indentation in Python. I've gone over it quite a bit in the previous videos, but I want to cover it so we're all on the same page here. Writing colons and indenting is how Python knows when you're inside of a function, loop, conditional statement, etc. And it's probably the most important syntax thing to pay attention to when you're writing Python code. The best practice for indentation is to just use the tab character once to tab over. Indentation will cause errors in your program if it's not done correctly. Just remember, anytime we want to get inside of a block of code, like inside of a function, if statement, for loop, class, or whatever it may be, you will always need to indent. Let's say I try and write a for loop something like this. Let's say for I in range 0 to 10. And I type a colon, except in this line I don't indent, and I'm just going to print out I. If I try and run this, it might take a second, I'm going to get an error because I didn't indent after putting a colon. And just give it a second more. And there we go. So you see there's an error here because I didn't indent, and it specifically says expected an indented block. And if I were to do something else, let's say I were to take this colon away and I were to indent, I would also get an error because I need both the colon and the indentation. So the golden rule is that colons and indentation go hand in hand. So after you have a colon, you must indent. And to get inside of any block like a for statement, you need to indent as well. So now if I run this, you'll see it prints out correctly. Where you have to start really paying attention is when you're multiple levels of indentation in. So let's delete this. I'm going to clear this output here. Oops. And let's say we have a function. Let's say def my function. And inside of this function, I want to do a for loop. So let's write for I in range 0 to 10. Now inside of this for loop, I want to have a conditional. So I'm going to write if I greater than 5. Then inside this, I want to print something else like this. Let's just print out I. So now I have 1, 2, 3 levels of indentation going on. So if I write at this first level, I'm writing inside the function. If I'm writing at this level, I'm writing inside the for loop. And if I write at this level, I'm writing inside the if statement. So just always try and be mindful of how many levels of indentation you have. And again, indentation is super important, and bad indentation could cause you to be troubleshooting bugs for long periods of time if you don't know what you're looking for. Speaking of troubleshooting bugs, I want to talk about that next. There is absolutely no avoiding errors and bugs in your program. No matter how skilled you are, you're always going to run into problems. Even programming experts run into errors all the time. What makes a good programmer is finding out how to efficiently solve these bugs. If you type something into your code editor that isn't valid Python code, or you just try and do something funky, the computer is going to complain and throw an error message. So for instance, let's just delete all this, and I'm just going to write something like, let's say print z. Now if I run this, I'm going to say, the error is going to say name z is not defined, and that's because we never ever defined a variable named z. So how do we solve this here? If you're a mediocre programmer, you'll sit there and try to figure out the error for yourself. However, if you're an amazing programmer, what you'll do is take this error, you're going to go ahead and copy it, go to the next tab, paste it like this, and you'll be introduced to this magical site called Stack Overflow. Stack Overflow is a site that allows programmers to ask literally any question about programming, and other programmers can answer that question. If you're having an error or problem with your code, there's a 99.9% chance that someone else has had that exact same problem and the question has been asked and answered on this website. As a programmer, Stack Overflow is going to be your absolute best friend, so get used to visiting it. It's so popular, in fact, that if I actually go back to Collaboratory and I have this error, you'll see there's a whole button underneath this error design that literally just says Search Stack Overflow. A lot of the other editors have something similar that will link you to the Stack Overflow to explore any errors that you're getting. But what happens when your code is not running as expected, but you're not getting any errors? Of course, you could search it on Stack Overflow because Stack Overflow doesn't just include errors, but many times you'll need to reread through your code and evaluate what's actually happening. Let's delete this here. And let's say we have a function, let's call it double number. And we're just going to give it one argument, number, and the goal of this function is to return double of whatever the number is that we pass in. So in here, let's just write 2 times number. Then outside of this, I want to make a variable, let's just call it x, and I'm going to set it to equal to double number 4. Well, if we double the number 4, that should be equal to 8, which means x should be equal to 8, right? But if I go ahead and write print x, you'll see that it prints out none. So what's actually happening here? Moments like these can be confusing because you're not getting an error in your code, but something is obviously going wrong. And so we look at what our code is doing and realize, oh hey, in this line, we're not actually specifying a return value in this function, and we forgot the return keyword. So now let's just write return, and now if we run this code, you'll see it'll no longer say none, and x will now be equal to 8. Computers don't really ever make mistakes when it comes to software because computers only do exactly as they're told. If there is an error in your code and your code isn't doing what you want, the mistake is from the programmer, not the computer. So as tempting as it may be to say, wow, this computer is stupid and doesn't understand what I'm trying to do, remember that a computer is only as smart as the programmer. In regards to getting errors, you just have to adopt the mindset that, oh, this means I did something wrong, not the computer. Something I talked about in episode 2 and episode 6 was naming conventions. So by naming conventions, I mean how we typically name variables, functions, and classes. So recall that to name any of these, we cannot have any spaces, we cannot have any special characters besides underscore, and we cannot start these names with a number. A few examples of perfectly correct names would be my variable, my function, variable 1, variable 2, and so forth. In terms of style, it is mostly up to you how you want to write names, but your name should always be relevant to what you're trying to do. So if you're capturing user input and storing it in a variable, you should probably call the variable user input or something that can tell you what it means. In a lot of the examples throughout these videos, I used x or my variable or my function or super generic names like those to name variables. But in reality, those names don't indicate what the variable actually does, so try and stay away from those super generic names. We also went over 2 styles for naming variables, camel case and snake case. So camel case is when you make the first letter of the variable or function lowercase, and then every word after that starts with uppercase. So you're basically separating words by capitalization. So an example of some camel case variable names would be my variable, user input, or big variable, or something like that. Snake case is when instead of separating by capitalization, you separate all words by underscores and everything in the name is lowercase. So the exact equivalent variables in snake case would be my underscore variable, user underscore input, and big underscore variable. Either one is fine, but some people prefer one or the other, so it's good to know both styles. These rules apply to functions and variables, but classes are a tiny bit different, so I'll make this note down here. It's good practice to always capitalize the first letter of a class. And this is so that as programmers, we can differentiate a class from other data types. So examples of class names would be car, dog, animal, and something like that, where we're just capitalizing the first letter. So everything else, like variables, functions, and so forth, should pretty much always start with a lowercase letter, while classes will always start with an uppercase letter. Another thing that I wanted to cover that I think is super important is methods that are associated with strings and lists. So methods are basically like functions, except we always use them with a string or list or some other data type, and we can use them by using the dot operator. So remember when we used append, remove, pop, and those kinds of operations when working with lists? Well, those are called methods, specifically list methods. So to use methods, we'll always have a variable that's a list or a string. So let's make one. Let's just say my list equals 1, 2, 3, 4, 5. Then to use methods, we'll type the variable name, like my list, the dot, and then whatever method we want to call. So let's say we want to call the append method, we would just do mylist.append, and then we'd fill in whatever we want here. So let's say 6. Python has a ton of built-in methods, so I'll go over a few with list first that we've already learned. For all these examples, we'll just use this mylist variable, but obviously this name can be whatever we want. So to add an element to the end of a list, we'll use this .append method that we've already written here. So we entered 6 inside the parentheses, so that means we should add a 6 to the end of my list. So let's actually print out my list here, and you'll see if we print it, there is now a 6 at the very end. To remove an element from the very end of a list, we would do something like .pop. So after we've added the 6, let's do mylist.pop. And now this should actually remove the 6 that we just added. So you'll see if we print it, it's just back to 1, 2, 3, 4, 5. To clear all the elements of a list, we can use mylist.clear. And now if we run it, you'll see the list is completely empty. To copy all the elements of a list, we can use something like mylist.copy. So the list of methods goes on and on and on, and I'll link a page in the description where you can see all these different built-in list methods. You do not need to know all these by heart because honestly you can just look them up if you need them, but knowing them might help you out in the long run. Strings have these same methods too, and you can use methods with them just like we can with lists. So let's clear all this out here. I'm going to clear the output, and let's make a new string. We'll just call it mystring, and I'll name it after myself, so I'll just name it Austin. So let's go over some of these methods that we can do with this string. And the main difference between string and list methods that is super important is that string methods will not change the original string at all. So if I want to do anything with string methods, I need to make a new variable from it. Let me show you what I mean by that. So there's a string method called lower that puts all the letters of a string into lowercase. So if I call mystring.lower like this, and then I try and print out my string, we'll see if we run it, notice how there is still a capital A in the front and not all the letters are lowercase. This is because string methods do not modify the original string at all. If I want to apply this method, I need to make a new variable to actually see it. So let's actually write my second string instead of equal to mystring.lower. And then here we'll print out my second string. And then now if we run it, you'll see now all the letters are lowercase because it has actually applied the .lower method. Let me now show you a couple of other string methods. So similar to lower, we can also use upper to make a string entirely uppercase. So if I replace this .lower method with upper and I print out my second string, you'll see that Austin is now all capitalized. There is also a function that checks if a string is entirely uppercase or not, and it's simply called isUpper. So isUpper will basically return true if the entire string is all uppercase, and it'll return false if the entire string is not uppercase. So in here, I'm going to write my second string .isUpper, and because we've already capitalized this string here, this should return true. So if we print it out, you'll see it prints out true. Another useful thing that you can do with lists and strings is called slicing. So slicing allows you to only look at certain parts of strings or lists. To slice a list, we would use square brackets that you should hopefully now be familiar with. So I'm going to delete this and make all this room up here free. I'm going to make a new list, call it my list. I'm going to set it equal to 2, 4, 6, 8, and 10. And let's make a new variable. Let's call it my slice list. And to slice, we're going to use the square brackets and some slicing operator, which we indicate by a colon. And I'll show you what I mean. Let's say we want to get this slice list to just grab 2, 4, and 6 from this original mylist variable. To do that, we would write mylist square brackets 0:3. Now this is basically saying to grab the indexes of my list from 0 to 3, but not including 3. This ending index here after the colon won't be included in the slice, meaning we're really just grabbing indexes 0, 1, and 2. So now if we go and we print out my slice list, you'll see that it prints out 2, 4, and 6. What if I wanted to grab 2, 4, 6, and 8? Then we would just change this 3 to a 4 here because we're grabbing indexes 0, 1, 2, and 3 now, which is just 2, 4, 6, and 8. What if I wanted to just grab 6, 8, and 10? I could do a similar thing, except I want to start with index 2 because that's where index 6 is. So let's do 2, and then we want to grab indexes 2, 3, and 4, so we'll have to have this one as a 5 here. And now if we run it, you'll see it prints out 6, 8, and 10. One neat thing is that you don't actually need numbers on both sides of the colon if you don't want. So let's say I wanted to grab everything from index 1 onwards. I could just write it like this. I would write 1, and it'll print everything out from index 1 all the way to the end of the list. So you see it prints out 4, 6, 8, and 10. If I wanted to do index 2 and onwards, I could just replace this 1 with a 2, and if I print it out, you'll see it prints out just 6, 8, and 10. So there's a lot of different ways you can do slicing with this. If I wanted to grab everything up until a certain index, I could do the opposite of this. So if I wanted everything up to index 4, I would write :4, because this is everything up to index 4, but not including 4. So if I actually print this out, it just prints out 2, 4, 6, and 8 because it's grabbing indexes 0, 1, 2, and 3. If I wanted to print everything up to index 2, but not including index 2, I would just write :2 like this, and you'll see it just prints out 2 and 4. So basically, if you write a number before the colon like this, let's say 2 colon, and you print that out, it'll grab everything from that index until the end. If you write just a number after the colon, it'll grab everything up until that index, but not actually including that index, so it would just print out 2 and 4. It's certainly not essential to know this, but it's a useful trick if you ever need to mess around with or manipulate some list, and you can do this exact same slice operation on strings as well. The reason I wanted to cover all these topics with you guys is to drive home some key concepts and some other useful tools that might help you out when you're coding in Python. I want to take the rest of this video now to talk about how you can move forward in Python and what your next couple of steps could be. Throughout these videos, I've taught you essentially all the key topics that you'll need to know as a beginner in Python. But if I just gave you all the tools necessary to build something, what good are they if you don't actually know what to build? So the most important thing moving forward with Python is actually building your own programs and working on your own projects. This is by far the best way to apply what you've learned, which in turn helps you learn so much more when you actually get some practical experience. Programming projects are also showcased to potential employers when you're looking for programming jobs. Employers want to look at what projects you've done because those projects help them gauge what kind of programmer you are. So the question is, moving forward, what kind of project should I work on? And here's where I tell you. The type of project you do should be dependent on what interests you. Are you interested in machine learning and data science? Grab a free dataset off a site like Kaggle.com where there are countless datasets over any possible topic. Then maybe take a look at the Pandas library for Python that can help you out with all different types of datasets. Hop into a Google Colab notebook and start coding. Look up tutorials if you need to, Google as many Stack Overflow questions as you need, but just get started. What about if you're interested in making games in Python? You should check out Pygame, which is a simple Python library that can make some fun little interactive mini games through Python programming. Maybe you want to make a Hangman game or Connect 4 or Checkers or some basic game like that. Look up some videos on how to use Pygame, hop into a Python editing environment, and get started. What about if you're interested in using Python for databases and web development? Check out MongoDB, which is a free-to-use database that can be accessed using Python. Read some of their tutorials, hop into an editing environment, and get started messing around with some of the code. No matter what project you want to do, the biggest and most important rule with this is to just get started. Even if you don't know what you're doing, just try to get started and look up help when you need it. If you get stuck in the learning phase where you're just endlessly watching YouTube videos all day but not actually coding anything, you're going to learn practically nothing about Python. Real programming expertise comes from working on your own projects and actually doing it. Surprisingly, actually coding is how you become a good programmer, not by watching 100 YouTube videos and not coding at all. If you're completely lost on where to start, I've compiled a list here for you with a ton of different project ideas. Just pick one of these that interest you and see what you can do. There's a few simple game ideas like a number guessing game, hangman, dice rolling, rock, paper, scissors, tic-tac-toe, and so forth. If you want to get more advanced with your games, you can build something like the snake game or something like Connect 4. And another popular project among intermediate programmers is building a calculator app. If building bots interest you, you can try making a Discord bot or a Reddit bot in Python or something like that. And there's a couple of data science things too, which are pretty cool. You could analyze your own Amazon spending habits using Python. You can analyze your Netflix watching habits. You can analyze some survey results, maybe analyze some salaries of different jobs, and so forth. In future videos, I may go through some of these project ideas to show you how I might go about building them. I guarantee you there are tutorials for every one of these projects that I've mentioned here that you can watch if you need a bit of a boost in getting started. Just remember that to get better, you should actually be coding to get some real-life practical experience. I really hope you've enjoyed this Python for Absolute Beginner series, and I hope that I've been able to help you out in getting started with your Python programming journey. Stay consistent with it and keep working hard, and I'll promise you'll become proficient. Becoming a programmer isn't easy, but you absolutely do not have to be a genius or even very smart to become one. Keep working hard at it and you will see how significantly you're going to improve over time, even if you're just learning one tiny thing each day. You're going to have roadblocks and problems along the way, but every time you get past one of those, you're that much better at programming because you learned something new. I believe in you and you should believe in yourself too. You can do whatever you set your mind to, and learning programming is no different. On that note, I'll leave you to start your journey, and hopefully I'll see you again in my future videos. Take care.